everyone, welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. Hi everyone, so am I visible to all of you? Yes, okay. Yes, bacha. Okay, so today we are going to complete chemical equilibrium along with ionic equilibrium with detailed information, detailed explanation and with the questions. Okay, we are going to practice a lot of questions today that are asked in your NEET examination. So are you all ready for that? So I was preparing this slides for you so that things are smooth in the lecture. That's why I got a little late. Yes? Okay, yes everyone. Are you all ready for the class? Everyone in the chat box, are you all ready for the class? So bacha, today's class is going to be very important. The reason here is that because these two chapters combined together, chemical and ionic equilibrium becomes equilibrium. That part is very important and students usually get confused, especially in ionic equilibrium. Chemical equilibrium is still easy, okay, that is easy chapter. But ionic equilibrium, it has so many formulas and we don't know which formula to apply where, especially in calculating the pH value. So there are few things like calculating the pH value, solubility product and solubility, all these things we are going to solve today itself. So are you all ready for that? Yes, bacha. Okay, everyone, green hearts in the chat box. Yes, everyone, green hearts in the chat box. Yes, everyone in the chat box, I want energy from you. Where is the energy? Right? There should be full amount of energy in the chat section. Otherwise, seeing your energy, my energy goes down. That what is happening? Why they are sleeping? Don't sleep in the class, okay? So be awake. This is Sunday and we are taking your class because I want to complete everything in detail. Not like you, okay, we do this chapter and you don't understand anything. No, I don't want that. I want all of you to understand every single step in detail. Yes, bacha. Perfect. So chalo, let us start the session with chemical equilibrium. So with the chemical equilibrium, starting from the very basic thing. So first thing, that is what is equilibrium, everyone. First thing, I know everybody is going to ask how long will the session be? Around 3 to 4 hours, okay, not more than that. Okay, around 3 to 4 hours, not more than that. So now we are going to start with introduction. What is equilibrium? So now bacha, what is equilibrium? For example, you have this bucket and I have this bucket has a hole and here the water is going down from this side, okay, and the water is coming from this tap, right? For example, on a constant rate, okay, the water is coming down and the water here is going down back to the ground, right? So in this case, what you will observe that seeing this view, okay, for example, the volume is this much, okay, the volume is this much for the beaker, right? I am watering this, right, and the water is going down from this tap. This is tap number 1, this is tap number 2, right? So even though constantly there is water, I am adding the water constantly, water is going constantly, what I see here that there is no change in the volume, right? There is no change in the volume. Here we have no change in the volume, right? So it may seem that we are not adding any water, right? If you see only this part, you will face that, okay, we are not adding any water, but actually we are adding the water. Same is the case with chemical equilibrium. That is why it is known as dynamic equilibrium. Dynamic means, what do you mean by dynamic, bacha? Dynamic means change, okay? Dynamic means change. Dynamic means always in constantly changing. But equilibrium means doesn't change. So what does that mean? That equilibrium is not static. If we say that equilibrium is achieved, this does not mean that the reaction has stopped. Okay. For example, you have A plus B that is converted into C plus D. Okay. Initially you had just reactants. After that, reactants are getting converted into products. Okay. Initially you have just reactants. Products are 0. Then you have reactants as well as product. Now there is a state of equilibrium where you see all the concentrations are constant, right? Where you see concentrations are constant. Okay, concentrations are constant. Here what you will see, at equilibrium, all the concentrations will be constant. Here what you will see, suppose this is A, this is B, this is C, this is D. Okay, it will be constant at equilibrium, right? No change in the concentration. But we cannot say that concentration is same. We cannot say the concentration is same. That may be same, that may be, or that may not be same. Or that may not be same. That is why we say this is dynamic equilibrium, not a static equilibrium. It is constantly changing. Now you say, ma'am, you said concentration is constant, so what thing is changing? Constantly reactants are getting converted into products and products are getting converted into reactants again and again and again. The rate of conversion of reactants to product and products to reactants is constant. Okay, so what I am saying here, I am saying that you have this A plus B, at equilibrium you have C plus D. The concentrations are constant here, but still we are saying it's a dynamic equilibrium. That means here we see there is change in the rate. Okay, the rate of forward reaction equals to rate of backward reaction. Okay, equals to rate of backward reaction. Forward reaction means we are converting reactants to products, and backward reaction means we are converting products to reactants. So concentrations are same, concentrations are constant. They are not same, they can be same, they cannot be same. But the rate at equilibrium is same. Okay, it is constant, it is same. Yes, bacha? Very good. So what we concluded, that at equilibrium, we have concentration, everyone, that is constant. Okay, that is constant. May or may not be same. May or may not be same. May or may not be same. That is not important that it should be same, right? But if we say rate will be same and this will be constant, and this is going to be constant. Clear to everyone here? Yes? Any doubt till now? Rate is same and constant. Now let us see few other examples of this. Okay. Let us draw some graphs, right? Let us draw some graphs. For example, you have this graph, right? This is between concentration and this is between time. Okay? This is between concentration and this is between time, right? Okay? So what we are saying, with pink I am denoting reactants, with blue I will be denoting products, right? So I am saying reactants are decreasing. Okay? Reactants are decreasing. And products are increasing. Here I am drawing this graph that reactants are decreasing and the products are increasing. So everybody, this is graph number A, this is graph number B. Which is true? Out of this, which graph is true? Out of this, which graph is true? Here we can see these are the reactants, okay? Pink I am denoting the reactants. These are the reactants and these are the products. These are the reactants and these are the products. Okay, this is the concentration. So what I am saying here, that the reactants is decreasing, product is increasing. But here what I am mentioning, that this part is equilibrium. Okay, here equilibrium has reached. Here we have equilibrium. Here I am saying that this part is going to be equilibrium. Everyone, which is true? That this part is going to be equilibrium. Right? That this part where concentration is constant is going to be equilibrium. So, here we see concentrations are not only constant, but they are also same. But it may be same, it may not be same. So, this graph is not true always. This graph is not true always, or we can say this may or may not be true. Okay, we can say this may or may not be true. May or may not. May or may not. It's not definitely true. If we talk about B, it is always true. It is always true. This graph is always true because concentrations are constant at equilibrium. They are not same. So this is always true. Right? Okay? Yes. Now, next graph that I am drawing between, we have this one and we have this one. So everyone, this is rate, this is time, this is rate, this is time. Okay? This is a rate of forward reaction that is decreasing, right? Rate of backward reaction that is increasing, right? Then I have rate of forward reaction that is decreasing, and here I have rate of backward reaction that is increasing. Okay, that is increasing. And these are same. These become same. So now, if we talk about rate, right? Rate at equilibrium. If I say this is the point of equilibrium, right? This is the point of equilibrium. This is the point of equilibrium, right? Where the rate is constant. So rate should always be, right? Rate should always be constant and same. That means rate of forward reaction. If we say this is the rate of forward reaction, this is the rate of backward reaction, rate of forward reaction, rate of backward reaction. Rate will always be same at equilibrium. Rate of forward reaction is always equals to rate of backward reaction at equilibrium. Not only constant, they are always equal. So I'll say this is not true. This A is not true, okay? And this is true. This B is correct, okay? This is correct. Yes, everyone, B is correct. A is always, in all the conditions, this is false. Any problem till now? Okay, understood this? A, what is the scene with concentration and what is with rate? Right? Okay. Okay, everyone. Now, let us see some differences here. See this, okay? Irreversible reaction and this is reversible reaction. Irreversible reaction, that is not reversible, okay? That is just going and going and going in forward direction. If something is going in forward direction, that will never be at equilibrium because it is not reversible. Only the reversible reactions can attain equilibrium, right? Because if something is not getting back to reactants, how can we say this can achieve equilibrium, right? So what we will say, irreversible reaction, a reaction which proceeds in forward direction only, do not attain equilibrium state, never attains equilibrium state because there is no backward reaction. There is no rate of backward reaction. So how can we say this can attain equilibrium? Generally, thermal dissociation are held in open vessels. These are irreversible reactions. Okay, so let us talk about the reversible reaction, in which backward reaction can occur, in which products can get back to the reactants. Now here the reaction which proceeds in forward as well as backward reaction attains the equilibrium state and never go to completion. Okay, there is one equilibrium state they will attain and we will feel that concentration is constant, right? The rate of forward reaction is equals to rate of backward reaction. There will be one state of equilibrium, right? So these are the examples of thermal equilibrium. Enclosed vessel is the example of, because no product we are losing here, right? Okay. Next is the type of equilibrium, bacha. Now we have two types of main equilibrium, starting with physical and chemical equilibrium. Chemical equilibrium, firstly let us talk about physical equilibrium. When there is change in the phase, for example, there is melting of ice, there is boiling of water, there is sublimation, all these things are phase changes. Okay, for example, H2 is getting converted to, this solid is getting converted to liquid and then to gas. So now this is a phase change. In phase change, we say we have physical equilibrium, right? We have physical equilibrium. Equilibrium in physical processes is called physical equilibrium. So these are the phase changes equilibrium. Then we have chemical equilibrium. Chemical equilibrium is that in which we have a reaction, right? There are different products, they are reacting with each other and we have the formation of new product, that is called chemical equilibrium. Yes, bacha, everybody, that is called chemical equilibrium. Yes, everyone. Very good. That is called chemical equilibrium. Next thing that we have is homogeneous and heterogeneous. These are small terms, okay? Homogeneous equilibrium is when we have all the phases of products and the phases of reactants, right, will be same. This is gas, this is gas, this is gas. Gas, okay? No differentiating of phases. But in case of hetero means many, right? And homo means one. So when we are talking about many phases, so there will be more than one phase here, right? For example, this is solid, this is gas, solid, this is gas. So there are more than one phase in reactants and product. Then we say this is heterogeneous equilibrium. Next, bacha, let us talk about the equation here. Let us talk about the equation. So let us talk about this equation, okay? For example, everyone here, for example, we have this reaction AA plus BB plus BB. At equilibrium, it becomes CC plus DD, okay? This is the equation, right? And the concentrations at equilibrium are A, B, C, D, right? These are the stoichiometric coefficients, right? Small a, small b, small c, small d are the stoichiometric coefficients, right? Okay, so now what we will see, the rate of forward reaction, okay? The rate of forward reaction will be equals to, proportional to A raised to power A, B raised to power B, okay? Raised to the power the stoichiometric coefficients of the reactants, right? And when we say rate of backward reaction, for this backward reaction, these are the reactants. For this backward reaction, these are the reactants. Rate is going to depend on the reactants, how many reactants it has, right? So this is R. Rate of backward reaction is directly proportional to CC, and this is DD. Right, and this is DD. So now we know at equilibrium, what we say, rate of forward reaction is equals to rate of backward reaction. You can also write it here. You can also write here that this is equals to RF is equals to KF. That is rate constant for forward reaction. This is rate of backward reaction is equals to rate constant for backward reaction multiplied by the concentration raised to the power the stoichiometric coefficients, right? So at equilibrium, what I am going to say, wait. Okay, so rate of backward reaction. Note should be good, no? Note should be good, right? Because you have to study these notes, so notes should be, look beautiful when we see it, so that we, feel like reading it. So now next thing is rate of at equilibrium. What we see at equilibrium, rate of forward reaction is equals to rate of backward reaction. So we say Kf A raised to power A, B raised to power B equals to Kb C raised to power C and D raised to power D, right? Okay, in that case we can say Kf by Kb, okay? Kf by Kb equals to, this goes here, that will be equals to Cc by Dd by A raised to power A and B raised to power B, right? And this is equals to the equilibrium constant. So here what we can say that Kc is the equilibrium constant, is equals to concentration of product raised to the power stoichiometric coefficient divided by concentration of reactants. Okay, this you have to remember for all the questions that you are going to do for equilibrium. Right, everyone, this is law of mass section. Yes, very good. This is law of mass section. So now this is a reversible reaction. Here we have derived that rate of forward is equals to rate of backward reaction. Right, okay. So now let us see some of the important points of equilibrium. This is dynamic equilibrium. Okay, why we say this is dynamic? Because there is change in concentration but that will be constant. The rate of forward is equals to backward. That way concentration are constant, but still we are adding some reactants. We are, the reaction is taking place, right? Next is at equilibrium, the reaction proceeds both the sides, okay, that is proceeding forwards and backwards. Equilibrium can be obtained from either side of the reaction. It can be backward, it can be forward. Next we have a catalyst. We are going to study this in detail. Can alter the rate of approach of equilibrium. It can increase or decrease the activation energy depending upon if it's a positive catalyst or a negative catalyst. Usually we use positive catalyst, so it is going to decrease the activation energy, right? Okay, we are going to study that detail in chemical kinetics as well. Okay, so alter the rate of equilibrium, but it does not change the rate of state of equilibrium. But the state of equilibrium, that point where the equilibrium is attained, that is going to be same. At equilibrium, the free energy change is going to be 0. We know that delta S is going to be 0, right? We studied this in thermodynamics, right? At equilibrium, delta G is going to be 0, not delta G naught. Okay, always remember, delta G is going to be 0, not delta G naught. Is not equals to 0. That may or may not be equals to 0, right? So what they ask you, they give you a formula. Okay, we'll study a formula on this, and what they will give you, this thing is, this reaction is taking place at equilibrium. You have to find the delta G naught. This question is asked so many times in your NEET examination. Repeated question this is. Okay, next is equilibrium state can be affected by altering factors like pressure, volume. So here we are going to study Lee-Chatelier principle in detail for the change in concentration, pressure, temperature, all these things. Addition of inert gas, all these things we are going to cover in Lee-Chatelier principle. Yes, bacha? Okay. So next we have law of mass section already done, right? So bacha, see this very carefully. Now we have two things, okay? Active mass. If we are talking about liquids, right? In that case, we will take concentration as an active mass. If we are talking about gases, if we are talking about liquids, that will be concentration as the active mass. If we are talking about gases, pressure is going to be the active mass here, okay? In that case, here we say Kc and here we say Kp, okay? Here we say Kp, right? And here it is equals to Kc equals to concentration of products by concentration of reactants, right? Raised to the power the stoichiometric coefficients, and here it will be Kp is equals to, that is pressure of, we can just write it here, this is product. For example, the reaction is A to B, right? Okay, in this case, this will be B, this is A, this is BB, okay? This is BB, this is AA. If this is in concentration, this is a liquid, right? If this is a gas, it could be PB raised to the power B divided by PA raised to the power A. Here we are going to use the pressure, right? In case of gases, right? Okay. Okay, bacha. Yes, bacha. Okay. Okay. Now, next thing that we are going to talk about is, here we have talked about this also. Now, law of mass section, we have also done this. One important concept here, one important thing here, that active masses are dimensionless quantities, okay? Active masses are dimensionless quantities, okay? So, whenever you feel, okay, when they ask you active masses are dimensionless or not, they are dimensionless quantities, but for purpose we generally take them dimensions of molarity or partial pressure. Okay, this question can be asked that active masses are dimensionless. But when we represent active masses in case of concentration or pressures, in that case, we, for making this simple, we take this as dimensions, because this has dimensions, this has dimensions, right? Both of these quantities are dimensional, okay? Now, next thing, so also we have done, okay? Wait, I'm going to delete all these. Yes. Okay. Now next thing bacha, see, this is also very important. This is Kp is equals to Kc RT delta Ng. Where this delta Ng is going to be, the number of gaseous moles of product minus number of gaseous moles of reactants, and this is very important because very simple questions are asked from this part, right? Just need to calculate the value of delta Ng. They will ask you what is the value of Kp, what is the value of Kc, right? So let us do some questions based on this. The first question here is, bacha, okay. No, bacha, we have done that in thermodynamics, okay? Right? Okay. Now, given the reaction between two gases represented by A2 and B2 to give the compound AB. We have two gases, A2 and B2 to give the compound AB, okay? This is the reaction. At equilibrium, the concentration of A2 and B2, we are provided with this. If the reaction takes place in sealed vessel, that is the closed vessel, then the value of Kc will be, right? Value of Kc is going to be product by reactants. What is the value of product here, bacha? What is the value of product? That is AB square divided by A2, and this is B2, right? And this is B2. So what is the value of AB? This is the value of AB, this is the value of A2, this is the value of B2. Right? Okay? This is the value of B2. Yes, bacha? Understood this? This is AB, this is A2, this is B2. Just put the values here and you will have the answer. Right? Just put the values of AB, A2 and B2. You will get the answer here. See the units. If the reaction, okay. Yes. Yes, bacha, everything is in molarity. So what is going to be the answer? 0.62. Just solve this and do the calculations, you will have your answer. Okay? Yes? Simple? Okay. Next thing is 20-liter container at 200 kelvins. Okay. Temperature is given to you. 20-liter container, volume is given to you at 200. This is the volume. Contains CO2 at pressure. This is the pressure. Okay, this is the volume. This is the pressure. Yes? Okay. Now, an excess of SRO is added. Okay, when CO2, we have beaker of CO2 in which SRO, okay, is added. Neglect the volume of solid. Neglect the volume. The volume of container is now decreased by moving the movable piston in the container. Volume is decreased. The maximum volume of the container when pressure of CO2 attains its maximum value is this. Okay. So let's talk about this one, okay? Let's talk about this equation. In this equation, the value of Kp is going to be, this is the solid, okay? Solid pressure we do not take, we neglect the pressure of solid, okay? We neglect the pressure of solid as well, only gases is taken, right? So pressure of product is going to be only the CO2, right? And this has stoichiometric coefficient 1. The pressure of solids are taken as unity, right? Okay, so here the answer will be 1.6 into PCO2 is the pressure of CO2. What we have to calculate? We have to calculate the maximum volume of container when pressure of CO2 attains its maximum value. You have to calculate the volume in this case. Okay, this is the reaction in that case. You have Cr2 and you have this. So let it be, this be the V2, right? You have to calculate the value of V2, right? And if we take this as V1 and this as P1, if this is V1, this was the initial condition, right? This was the initial condition. But for example, you have this beaker. Initially, you have this pressure P1, V1, right? Then you add SRO here, right? The SRO here. Then this is going to be P2, V2. We have calculated this. We have to find the value of this, right? We have calculated this one. We have calculated this one. We have to find the value of V2, and this is given to you. This is also given to you. See, 20-liter container contains this much of CO2 at pressure this much, and excess of Cr2 is then added. Okay, just apply the formula, that is P1 V1 is equals to P2 V2. Just apply this formula. P1 V1 equals to P2 V2. After applying this formula, what you will get? P1 is equals to 20 liters. This is 20 liters. What is V1 is equals to? This is V1 is equals to 20 liters, right? P1 is equals to V2. You have to calculate. This is 0.4. This is 0.4, and this is 1.6. So V2 is going to be 0.4 into 20 divided by 1.6, and this is going to be your answer, and this will be in liters, and this is going to be in liters. Why? Because this is given in liters. This is in liters, so this answer is also going to be in liters. Yes, so what is going to be the answer? Yes, bacha. They have given temperature just like that, okay? They will give you some extra information also, right? But there is no use of temperature in this, yeah? There is no use of temperature in this particular question, right? Okay, you just have to see which formula is applied here. Like we are diluting something by adding water. We say M1 V1 is equals to M2 V2. Similarly, here we say P1 V1 is equals to P2 V2. Right? This is a constant temperature they have given. Okay, the temperature here is constant. It is representing basically isothermal process. Right? Okay. Yes, bacha. Okay. Okay. Yes. Understood. So what is going to be the answer? 5 liter. Let us see. Yes, 5 liter is the answer here. Okay. So this was your NEET 2017 question. Let us see next, in which of the following equilibrium Kc, Kp are not equal. In that case, you just need to find where delta Ng is not equals to 0. Okay, we have to calculate delta Ng by number of moles of gaseous product minus. Okay, gaseous products, not only products but gaseous products that are in gaseous state. Right. So this is in gaseous state. Let us find this out. Here delta Ng is equals to, this is 1, 2 minus 2, that is going to be 0. Here we have 2 minus 2, again this is going to be 0. This is 2 minus 2, again this is going to be 0. Here we have 2 minus 1, this is solid, so we are not going to calculate this, right? 2 minus 1, this is going to be 1, so answer is going to be D here, right? Very good, okay? Very good. Next we have factors affecting equilibrium constant. So now let us see the factors that affect the equilibrium constant. So very simple way I am going to teach you this. It's very simple, okay? Very, very simple. So see, first case what I am going to take here, that if you have a reaction, say if you have a reaction A, if you have a reaction A is getting converted into B, okay? It is getting converted into B, right? So in the first case, if you multiply this with any number n, okay? If you multiply this with any number n, here you have the equilibrium constant K1. If you multiply this with any number n, this will be Na, Nb, right? So what is going to be the value of K2? That is going to be K1 raised to the power n. Okay? Whatever number you are multiplying this with, okay? This n can be 2, half, anything. This can be in fraction, this can be an integer, any value. For example, if I multiply this with half A, half B, okay? For example, initially it was A give 3A give rise to 2B, okay? And here this is K1, and then you have to calculate the value of A by 2 A, this is B. You have to calculate the value of this one, okay? So how you will calculate it? Because it is now multiplied by 2, okay? After multiplying with 2 only, we got this equation. Right, so this is K2. So K2 is going to be K1 raised to the power half. Okay, whatever is the number you are multiplying the original equation with, that will be raised to the power that number. Okay, that is the first case. Now, second is, if you have equation that is A give rise to B. Okay, and we are reversing it, and we are reversing the equation, and we are reversing the equation. If we are reversing this equation, what is going to happen? You are reversing this. Okay, that is B is converted into A, right? So for example, here I am taking this is K1 and this is K2. Okay, then what is the relation between K1 and K2? This is going to be K2 is equals to 1 by K1. Okay, this is going to be K2 is equals to 1 by K1. Yes, everyone. Now, third thing, if I have two equations, for example, I have equation A, B, and then I have A, C. Okay, I have A. Okay, I will be writing it another page, third page. Okay, so that is A, B, and you have, this is having K1, right? And you have C, D. The value of equilibrium constant is K1, and here we have equilibrium constant value K2. Now there are two things, okay? First thing is, if we add this and if we subtract this. If we add the value here, if we subtract the value here. If we add the value here, what is going to be the answer? If we are adding the value, right? If you are adding the two equations, right? That means that is A plus C give rise to B plus D, right? And if you are subtracting these two values, that is A minus C is going to be B minus D, right? Okay, and this is going to become A plus D, and this is B plus C. Okay, something like this. Now, this is this K3, this value of K3 here is going to be, if we are adding these two equations and there is formation of new equation, in that case the original two constants, equilibrium constants, will be multiplied by each other, right? This will be multiplied by each other. But in case of subtraction, okay, you are subtracting 1 with second, okay, so that will be K3 is going to be K1 divided by K2. Okay, understood everyone? Yes. Everyone, any problem? We have three cases. If you are multiplying this with any number, in that case, that will be raised to the power, original raised to the power n, right? First thing. Second thing is, if you are reversing it, if you are reversing this equation, in that case, the new equilibrium constant is going to be 1 by K1. That is 1 by initial equilibrium constant. Third is, if you are adding two equations, the equation that is the third equation that is formed by addition, the equilibrium constant of that will be multiplication of 1 and 2. And here if you are subtracting this, that will be equals to division of 1 and 2. Yes, bacha? Okay? Understood? Any problem till now? Okay. This is the chart here. For example, you have this equation that is K1. If you are reversing this, this is K2. If you have AC and this is K3. Wait. This is... Okay. This is actually, they are saying you are adding these two equations. Okay. Adding these two equations. I am writing it here. If you are adding these two equations. Okay. This is 1 and this is 2. Adding 1 and 2. Adding 1 and 2. If you are adding these two equations, after addition, these will be cut and you will have the formation of A and C. And this is going to be multiplication here. Right? Because I am adding two equations. Right? Okay. Then we have these two equations. In this equation, this is the first equation that is having K1. Right? And we are reversing this. I am reversing this. That will be, or now new equilibrium constant is going to be 1 by K1. Right? Now, next thing is that when we are multiplying this with any factor, here we have this one, and now I am multiplying this with half, okay? Multiplied by half. Multiplied by half. Okay, this is multiplied by half. In that case, this is going to be K1 and K1 raised to the power half, that is under root K1, okay? This is going to be the new equilibrium constant. Yes? Okay. Now let us see the values here. If the equilibrium constant for N2 plus O2 give rise to 2NO is K, right? This is the equilibrium constant. the equilibrium constant from half. Okay, that means you are multiplying this with half. Okay, this is multiplied by half. This is multiplied by half. So this is going to be the new K2 is going to be, or you can say the new K dash is going to be K raised to the power half. Okay, that is D is going to be the correct answer here. Yes, because we have multiplied this with half. In that case, the new equilibrium constant is going to be K raised to power n, where n is 1 by 2. Okay, so that is K dash is going to be under root K. Yes, everyone? Perfect. Now, next thing is factors affecting equilibrium constant. We have second thing, that is temperature. Okay, now this equation is very important. This equation is very important for you. Very important for you. Write it down. Very important equation. Right? That is log K2 by K1. We are talking about two temperature, that at T1 we have K1 equilibrium constant, at T2 we have K2 equilibrium constant. And we are comparing this with the enthalpy change. That is log K2 by K1 equals to, okay, log, natural log we are talking, that is log K2 by K1, natural log no, we are talking about log base to 10, right? If we are talking about natural log, this 2.303 won't be here, okay, that will be, this will be erased. In that case, you are talking about natural log here. So this is going to be log K2 by K1 equals to delta H, that is the enthalpy change, divided by 2.303 R, 1 by T1 minus 1 by T2. Very important equation, von Hoff equation, right? So from this equation, what are the conclusions? Okay, very important conclusions, that if we have exothermic reaction, if we are talking about exothermic reaction, if we are talking about endothermic reaction, if we are talking about endothermic reaction, so always remember this, in case of exothermic reaction, right, in case of exothermic reaction, we say that K is directly proportional to temperature, right? Just wait, yes. No, in case of endothermic, yeah, in case, this is inversely proportional, yes. Okay, so in case of exothermic reaction, equilibrium constant is inversely proportional to temperature, and in case of endothermic reaction, equilibrium constant is directly proportional to the temperature. See how we are using this. So suppose they have asked you one question, that always if they ask any question like if you increase the temperature, and that is an exothermic process, right? If you increase the temperature, that is an exothermic process, you will say increasing temperature, T2 will be greater than T1, right? Here you will say K2 will be less than K1, right? This is the answer here. For example, here we have increased the temperature, T2 is greater than T1, here K2 is greater than K1, right? This is the conclusion from this von Hoff equation, right? This is a conclusion from this von Hoff equation. Where temperature is increasing, we are also going to use this in Lee-Chatelier principle. Yes, bacha, any problem here? Any problem here? Right? This is actually derived from this equation only. You put the values here, right? You put the values here, you will get the answer. Because here the heat is released, okay? Here the heat is released. Delta H is negative here. And here we have delta H positive. And that is the reason everything changes here, okay? This is because of this delta H. Everything changes here, right? The delta H sign is positive or negative. That is the reason this whole thing changes here, okay? Yes, bacha? Okay, I am also writing this one thing here, that is delta H is, everyone, for exothermic reaction, delta H is negative, okay? And here we have delta H is positive, right? So these are the concluding parts for you that you have to remember in your exam, right? Next is few questions based on this. First question, everyone here. Yes, first question. For a given exothermic reaction, Kp and Kp dash are the equilibrium constants. So these two are the equilibrium constants. Okay. You have Kp and Kp dash, which temperature is T1. Okay. So for Kp you have T1 and for Kp dash you have T2. And always, now always we take, this is an exothermic reaction. Okay. Exothermic reaction. That means temperature is inversely proportional to equilibrium constant. Okay. Now assuming that height of the reaction is constant in temperature range between T1 and T2, it is readily observed that, okay, whenever you have T1 and T2, always take T2. If nothing is given to you, always take T2 is greater than T1. Right. Moreover, they are saying the heat of the reaction is constant at temperature this range. Right. Okay. So now let us see if they are talking about the exothermic reaction. T2 is more than T1. If you say T2 is more than T1, T2 is more than T1, and you know that temperature is inversely proportional to constant here. Corresponding to T2, we have Kp, we have Kp dash. This is going to be less as compared to Kp. So what is the answer? Kp dash is going to be less as compared to Kp. A is going to be the answer here. Okay. A is going to be the answer. How we did it? Exothermic reaction, we have, this is 2014 question. Okay. So in exothermic reaction, we have temperature is inversely proportional to equilibrium constant. Okay. So this is about exothermic. They say this is endothermic reaction, the answer would be B. Okay. For endothermic, answer would be B. But in this case, this is inversely, T2 is more than T1, Kp dash is less than Kp. Yes, everyone? Perfect. Now next thing we have, given that the equilibrium constant for the reaction, we have this reaction has a value. Okay, this is the value for, given that the equilibrium constant has a value this at a particular temperature. This is the value of equilibrium constant. What is the value of the equilibrium constant for the following reaction at the same temperature? So now you are just dividing this by half. Okay, you are dividing this by, you are reversing this. You are firstly reversing this and dividing this by half. Okay, you have reversed the equation, right? First thing, then you have divided it by half. Then you have divided it by half. Okay, then you have divided it by half. So the new K dash, everyone, the new K dash is going to be, this is K, for example, I assume this is as K. Okay, so firstly reverse it, 1 by K raised to the power 1 by 2, that is going to be 1 by 278 raised to the power half. Okay, 1 by under root 278, that is going to be the answer. Okay, so what is the answer? Everybody calculate this. This is 2012 question. Okay, 2012 question. Everybody, what is going to be the answer here? Yes. Everyone, what is going to be the answer? After calculating 6 into 10 raised to power minus 2 is going to be the answer. Calculation is your task. Okay, calculation is totally your task. Now, next thing, bacha, that we have, the equilibrium constant for the following reaction. This has been repeated so many times. 2003, 2017, 2007. After every 7 to 8 years, this is being repeated again and again. Yes? Yes. Else is math only. Right. Everything else is math. The chemistry part I'm teaching you. Calculation is your work. Okay, don't write it in exam that, okay ma'am, we know this, everything else is maths, because this is the MCQ based question. You cannot write, they will not give you any mark for 0.001 mark for this formula, right? You have to answer that, you have to do the calculation and answer it correctly. Only after that you will get the marks, right? Okay, so equilibrium constant of the equations of the following equation, K1, K2, K3, the equilibrium constant of the reaction. This is the reaction. Everybody do this yourself. Okay, I'm waiting for you to do this yourself. The same thing that we have done before. This is the same thing that we have done before. right? Same thing that we have done before. The equilibrium constant of the following reactions, that is N2 plus 3H2, give rise to 2NH3. This is K1. You have to answer this one. Here you know this was in product side and now this is in reactant side. This means surely this is reversed. Okay, this is surely reversed. This is surely reversed. Talking about this one, here you have N2 is not, okay, N2 is not added or subtracted, so this will be same. But this H2 is multiplied by 3, okay. This third equation is multiplied by 3 because here you have H2 and here you have 3H2. That means this is multiplied by 3, okay. This will be multiplied by 3, right. So here it will be multiplied by 3. So the answer here, everyone, the answer here is going to be K dash is equals to, this is the first K1 that is reversed, so that is why it will be here, okay, we will put it here, okay, this will be 1 by K1, this is reversed. So now K2 is same, okay, so it will be same, that is K2, but K3 is multiplied by 3, so it will be K3 raised to the power 3. Okay, this is going to be the answer. That is K2 into K3 raised to the power 3 by K1. This is going to be the answer. A is going to be the correct answer. Yes, A is going to be the correct answer. Very good. So this was your question that was repeated so many times. Now let us see the applications of equilibrium constant. Okay, let us see the applications. How to predict the reaction. Okay, the first equation, first thing that we are going to see, when you see the magnitude of equilibrium constant, how you predict whether it's a forward reaction, whether it's a backward reaction. So for that we have some standards. That is, we have 3 cases to this. Okay. For example, the equilibrium constant is more than 10 raised to power 3. Okay. It is more than 10 raised to power 3. We know that equilibrium constant is equals to product by reactants. In that case, what we can say, if it is more than 10 raised to power 3, that means it is product dominant, right? That means it is product dominant. That is why it comes out to be more than 10 raised to power 3. So here we will say this is more into producing more products. Okay, so that is going to be a forward reaction. Okay. Product favorable, or you can say forward reaction. Okay, we can say forward reaction. This is a product favorable reaction, that is forward reaction. Okay, now if we say equilibrium constant value is less than 10 raised to power 3, in that case what we are going to say, okay, this is less than 10 raised to power minus 3. In that case, this is very small value. That means product is very less. Right, and the reactants are more. That is why this is going to be so less, because this reactant value is very large. That is why equilibrium constant value is very less. Okay, so that means this is reactant dominant, and you have reactant product. If something is reactant dominant, that means it is more preferable to backward side. Okay, that means it is going to be a backward reaction. Okay, that is going to be a backward, that means it is going to be a reactant favorable reaction. The reaction is reactant favorable. Yes, bacha. Okay, so if it lies between 10 minus 3 to 10 raised to power 3, so this is appreciable concentration of both reactants and products are present here. Okay, yes, bacha. Next is, this is the same thing that is repeated. Okay. For example, you have Kp. If this is between minus 3 to K, this both reactants and product are present. If we say this is more than 10 raised to power 3, we'll say almost at completion, right? This is like going forward and forward and forward, right? If it is going backward and backward and backwards, that is when it hardly proceeds. We are making the products, again it is getting converted into reactants and reactants. Right? That means it is favorable in making reactants, not products. So this reaction hardly proceeds. Okay. Yes. Now next is going to be reaction quotient. Okay. Yes. Now what is reaction quotient? Now bacha, what is reaction quotient? We know equilibrium constant is product by reactants, right? Okay, so that is at equilibrium. If we say other than equilibrium, at any other point, the ratio of products by reactants is going to be QC. That is the reaction quotient. Okay, that is the reaction quotient. Yes, bacha, case 3 is backward. Very good. Okay, that is the reaction quotient. So here questions are asked so many times. So many times questions are asked from this one. Okay. So I'm going to make this very simple for you because this is actually very simple. For example, what they ask you, if you have a reaction where QC is more than KC, right? You have a reaction where QC is equals to KC. You have a reaction where QC is less than KC. Okay, this is KC. So in all these cases, what is going to be the answer? First you have QC more than KC. If QC is more than KC, see this. Every time what we need to do, we need to match QC to KC, right? If QC, if we have to make QC equals to KC, right? This is QC, this is KC, right? Now, in what way the reaction will proceed, forward or backward? Now we have to equate QC to KC. In that case, the reaction will be backward. This is backward, this is forward. Okay, this down part is backward, right? And this up part is forward. This is just a way so that you remember this in your exam, right? Okay, this is backward, this is up is forward, right? So it is going back here. So we will say in this case, if QC is more than KC, in that case we will say the reaction is going to be backward. The reaction is going to be backward, right? Now next thing that we have, if QC is equals to KC, if QC is equals to KC, everyone, in that case we say equilibrium has achieved. Okay, so we'll say this is equilibrium has achieved, right? If we say QC is less than KC, right? In that case, to equate it to KC, it has to go forward, right? So here we will say there will be forward reaction. There is going to be forward reaction. Okay, everyone, any doubt? Any doubt till now? Yes, this is going to be forward reaction. This is backward. This is at equilibrium. Yes, everyone, any doubt? Okay. Yes. Now, let us see this. This is what they are saying, that you have reaction quotient. Reaction quotient, that means reaction quotient is equals to products by reactants. Okay. So product are initially 0. We have initially 0 products and it increases at equilibrium state, right? This QC is equals to KC and KC is a constant value and that is why it becomes KC, right? So we'll write it here. At this point QC equals to KC, right? At this point QC is equals to KC. Yes, okay, perfect. Why there are so less students in the class? What happened? Maybe exams, board exams, is it? Very important chapter, I guess so. There are board exams going, because I asked students, they were saying they were board exams, so that is why they are preparing for that. So all the students who are watching the recorded version right now, if you have any query, just write it down in the comment section. Okay? Yes. So next thing, bacha, that we have is calculation of equilibrium constant. Okay, let us calculate the equilibrium constant. Okay, very simple. Through the formula only we will be able to calculate the value of equilibrium constant, right? So let us do the questions here. The reaction 2A plus B give rise to 3C plus T. We have the reaction 2A, school exams 2. Yes, I guess school exams are going on right now of 11th class and 12th class, both board exams are going. So yes, maybe that's the reason. Don't worry, I guess so they will watch, because students were saying, ma'am, you take the live session, we will watch the recorded. Yeah, at 2x speed we will watch. So okay. So now the reaction 2A plus B give rise to 3C plus T has begun. Okay, this should be is begin, not. has begun with the concentration of A and B both at initial value of this. Okay, so okay, let's do this reaction. This is A, B. We have A, B, C, D. Okay, this is 2A plus B. This is C plus 3D. Is it 3C plus D? This is 3C plus D. Right? So they are saying this reaction is begin with the concentration of A and B both at initial concentration 1. Okay, initial concentration is 1, 1, and here we have 0, 0. Right? At time t, when the equilibrium is reached, the concentration of D is measured and found to be this. Okay, equilibrium reached at equilibrium, this is found to be at equilibrium, this is found to be what? This is found to be 0.25. Okay, so let's do this. Okay, at equilibrium, if we say this is 0.25, right? If this is 0.25, if we say D is the concentration, here we have X, this is X, and this is 3X, and this is 1 minus X, and this is going to be 1 minus 2X. Okay, this is always 1 minus the number of moles stoichiometric coefficient into X. Right, this is the number of moles is 1, here the stoichiometric coefficient or number of moles is 3. Right, so we have provided with the value of X is equals to 0.25. Right, in that case this will be 0.50, right, and this is going to be 0.75, and this is going to be 0.75, and this is going to be 0.25. Right, so equilibrium constant is going to be product by reactant. So everybody, that is going to be product by reactant. What it is? That is C cube D1 divided by A whole square and B. Right? So just put the values here. Put the values here, everyone. Put the values here. Kc equals to C. The value of C is going to be, this is 0.75 cube, and this is 0.25 divided by this A is 0.50 square, this is 0.75. Right, I think the value is given in this form only. Right, so this is 0.75 cube, 0.25. Right, so everywhere we have this one. 0.50 square, 0.50 square, 0.50000, okay, 0.75. So the answer is going to be B. Yes, everyone, the answer is going to be B here. Yes, okay. Were you able to solve this question, everyone? Were you able to solve this question? Everyone in the comment section, are you able to solve this question or not? Yes, everyone in the comment section. Okay, now next question that we have, the reaction. Okay, yes, perfect. Okay, the reaction quotient for the reaction is this, is given by this. The reaction will proceed from right to left. Okay, right to left means it is a right to left, bacha. This is right to left, that means it is a backward reaction. Okay, for a backward reaction, always we have QC more than KC. Right, QC is more than KC. So D is going to be the answer here. Yes, bacha? Now QC is more than KC. So D is going to be the answer here. Right? Okay. We have done this now. This is QC, this is KC. If you have to go back, this will be the backward reaction. You have to equate QC into KC. Very simple trick to learn this. Right? Okay. Understood? Now, let us do this formula, that is delta G, or you can also write it as delta G equals to delta G naught plus 2.303 RT log base 10 Kc. Right? Okay? You can also learn this formula. And always remember, as I told you before also, at equilibrium, delta G naught is not equals to 0. Okay, at equilibrium delta G is equals to 0. Okay, always remember at equilibrium delta G is equals to 0. Delta G naught is not equals to 0. Okay, delta G is equals to 0. If you put the value here, you will get the formula. Delta G naught is equals to, you will get the formula delta G naught is equals to minus 2.303 RT log base 10 Kc. Okay. One thing here we will not write Kc, here we will write Qc. Okay, because this is before attaining equilibrium, this Qc is a reaction quotient. But after attaining equilibrium, this Qc equals to Kc. Right? Okay? Yes, bacha? Yes? Okay? So many questions are asked from this particular formula. Very, very important. Very, very important. Very, very important formula. Okay? Let us do some questions based on this. And also one more thing. If we talk about spontaneous or non-spontaneous process, you know from this equation that if we're talking about spontaneous process, that means delta G is going to be negative. If delta G is negative, this is minus, this is going to be positive. Okay, so this is going to be positive here, this is negative. For spontaneous reaction, we have delta G is less than 0, that is negative. Delta Q, equilibrium constant, is going to be positive. And bacha, for non-spontaneous, delta G is positive, that is why equilibrium constant is going to be negative. At equilibrium, K equilibrium is equals to 1, right? That is equals to 1 and delta G equals to 0. Okay, this is delta G. Wait. Do not write it here, delta G. Okay. Okay, so they are saying at equilibrium, see, do not get confused in this. Never write at equilibrium delta G naught is equals to 0. Okay, never write this. Okay, at equilibrium delta G equals to 0. Right now they are saying at equilibrium if delta G naught is also equals to 0. Because this is the condition for equilibrium. Okay, so I am writing it here. At equilibrium, this is the formula. This is the formula at equilibrium. This is the formula at equilibrium, right? So at equilibrium, you have this formula, delta G naught is equals to not equals to 0. Okay, that is equals to minus 2.3 RT natural log K equilibrium, right? But if we say that at equilibrium, you have another condition where delta G naught is equals to 0. See this, at equilibrium, delta G is equals to 0, delta G naught is not equals to 0. I think I should erase this only, because you will get confused in this. Okay, I am erasing this part because there is chances of confusion in this. So always remember, if at equilibrium you are saying delta G equals to 0, I will write it somewhere else at the next page. Okay. Now they are saying at equilibrium you have delta G naught equals to minus 2.303 RT log base 10 Kc. Right? This is the equation at equilibrium. Now if I say if delta G naught equals to 0 here, putting the value here, you will have log base 10 Kc equals to 0. That means Kc equals to 1. This is what they are saying. Okay? Yes? Understood? Non-spontaneous. Very good. Very good. Now, bacha, let us do some questions based on this. 2020 questions. Hydrolysis of 2020 question asked in NEET 2020. Hydrolysis of sucrose is given by the following reaction. This is invert sugar. Okay, this is hydrolysis of sucrose. Right, you have glucose and fructose. If the equilibrium constant Kc is this at 300, the value of delta G naught at same temperature, right? You have to calculate the value of delta G naught. If the equilibrium constant, the value of Kc is this. Okay, simply put this value, right? Simply apply this formula. Delta G naught equals to minus 2.303. They are talking about natural log, so do not write minus this. Okay, just write here minus RT natural log Kc. And what is the value of Kc? This is the value 2 into 10 raised to power 13. Right? Now what is the value of R? That is 8.314. Right? And what is the value of temperature here? That is 300. Okay. So Kc value is also given. So this is going to be the answer. Okay. A is going to be the answer here. Right everyone? A is going to be the correct answer here. Yes everyone? Okay. Now the equilibrium constant. This is NEET 2023. Last year question. Okay. Last year question this is. Now the equilibrium constant of species in the reaction A plus B give rise to C plus D. Here we have a 2, 3, 10 and 6 respectively. Delta G for the reaction. Okay. Now you have A plus B, C, D, 2, 3, 10, 6. A plus B, C, D. Now you have the equation at equilibrium, that is 2, 3. The concentration are 2, 3, 10, 6. Okay. This is 10, this is 6. This is at equilibrium. So Kc is going to be, everyone, what is the value of Kc? Kc is going to be, everyone, what is the value of Kc is going to be product by reactants. So this is 10 into 6 divided by 2 into 3. This is 5, this is 2, this is going to be 10. And the value of Kc is going to be 10 here. Now they have asked you in calories, they are asking you delta G, right? They are asking in calories. So here we have delta G naught is equals to in calories. And are they asking, okay, we can put any value here. So we will put the value of natural log because log base to 10 because we know the value of log base 10. Right? This is 10. So everyone, log base 10 equals to, log base 10 is equals to 1. Right? So delta G naught minus 2.303. R, they are given the value 2. This temperature is equals to 300 Kelvin, right? 300 Kelvin. So this is going to be your answer. This is going to be your answer. Right everyone? Yes? So just answer this question. What is going to be the answer here? 6, 2. This is a negative, negative, negative. The value is going to be this 2 here, 1, 2, 3. Okay. So this should be, I think B should be the answer, C. Okay. Just calculate this value and you will get the answer, that is C is the correct answer. Okay. Okay. Just do the calculation and you will get your answer here. Okay. Now, next question everyone. Next question that we have. Wait. What is this? CD, 10 into 6. This equation here is wrong, okay? Just see the equation that I have written, okay? The equation that I have written, okay? Yes. Now, let's do the last topic of chemical equilibrium. After that, we will take a break and we will start ionic equilibrium. Yes, everyone? Okay? Only 2 formulas are used. So now let us see Lee-Chatelier's principle. Very important conceptual questions are asked from this. Okay? Concept-based questions are asked from this. So I will give you some tricks to solve these kind of questions, and after that this is going to be very easy for you. So what is Lee-Chatelier principle? So he suggested that whenever you disturb the equilibrium, that is going to behave in an opposite manner. For example, if I say study, then you will say I won't study. If I say don't study, then you will study. Okay, so whenever we disturb equilibrium, when you say do that, it will not do that thing, it will go in an opposite direction and do the reverse of that thing, right? So that is Lee-Chatelier principle. That is always opposing thing that you have done to it. For example, firstly we will start off with effect of concentration. We are going to study all the effects here, starting with effect of concentration. So whenever I say you are increasing the concentration of reactants, okay, for example, you have this thing, reactants, and these are products, right? This has achieved equilibrium. If I say you are increasing the concentration of reactants, right, it will say I don't want to be here. You are increasing my concentration here. You are doing wrong thing. I will behave opposite. You are increasing my concentration of reactants. I will go in opposite manner. I will go in a forward manner. Okay. I will try to consume the increased concentration here, because everything in this world wants to be stable. So is this reaction wants to be at equilibrium state. If you're increasing the reactants, it will go in the forward reaction. It will go in the forward state. If you're decreasing the reactants, what will happen here? It is saying you're decreasing my reactants. That is so bad. I was so happy. I was at equilibrium. So now what it is going to do? It is going to do backward reaction here. Okay. It is going to increase the reactants. You are increasing the reactants. It is going to decrease the reactants by going through the forward reaction. You are decreasing the reactants. It is going to behave oppositely, and it is going to increase the reactants by backward reaction. Okay, by backward reaction. Understood? By backward reaction. Yes, bacha. Next thing is, if you say that okay, equilibrium, what I'll do, I will increase your products. Equilibrium will say, no, you can't do that. You are increasing my products. Now what I will do? I will decrease the products. How it will decrease the products? It will go in backward direction. That is how products will be decreased. So it will go in backward direction. Right? It will go in backward direction. Now if you say equilibrium, I am going to irritate you because I am very clever. I am going to decrease your products. So equilibrium will say, no, you can't do that. I was at equilibrium. You are decreasing my products. It will say you are decreasing my products. I will increase my products. I will behave oppositely. So it is going to increase the product and go in forward direction. And go in the forward direction. Everybody, is this clear to everyone? Yes. This is the Chatelier principle for changing the concentrations. Right? Now, let us see. So, addition of reactants forward, addition of reactants, removal of reactants backwards. We have done this, okay. Now this is a very important note, very important note, that if we increase or decrease the concentration of solids, it does not have any effect. Okay, it does not have any effect if the reactants or products are solid. If the addition of any solid component does not affect the equilibrium, right? Addition of any solid component does not affect the equilibrium. So how they will ask you questions from this? Everyone, how they are going to ask you questions from this? Tell me. How they are going to ask you question? They are going to say that suppose you have a reaction A plus B. This is C. Okay? And this is solid, this is gas, and this is also gas. Okay, so they are saying what we are going to see, we are going to increase the concentration of A. We'll say, or we are going to decrease the concentration of A. In that case, what we will write? There will be no effect. No effect, right? Why? What is the reason? No effect because solid increasing or decreasing, concentration of solid, no effect on equilibrium. this is going to have no effect on the equilibrium. Yes, Bacha, this is going to have no effect on the equilibrium. Yes, everyone, understood this? Everyone? Otherwise, equilibrium will take revenge later in exam. It is not going to take revenge in exam. It is going to take revenge here only. Right? It is going to take revenge from you in the Lee-Chatelier principle. Lee-Chatelier principle warned you about equilibrium. That do not disturb it. Okay? Like equilibrium get irritated very easily. That why are you irritating me? I'll do opposite whatever you say. Right? So now you have effect of pressure. Now ma'am, how to understand this? Pressure, you just need to understand one concept here. Right? Just one concept and everything will be easy for you. Now ma'am, what is that? I say, if you are increasing, just one line here you have to remember in this. Just one line. That is, if you are increasing the pressure, it will go, equilibrium will go in direction, it will go in a direction of where number of moles are less. Okay, if you are increasing the pressure, it will go in a direction where number of moles are less. Okay, now let us see what does this mean. Let us try to understand this whole concept. Right now, delta Ng. Firstly, let us understand what this delta Ng is greater than 0, less than 0 means. Okay, delta Ng, as you all know, delta Ng equals to number of products minus number of reactants. Right? Number of products minus number of reactants. So this is number of products. This is greater than this. We will say NP is greater than NR. That is, products are more than reactants. Here we say number of products are more than number of reactants, number of moles of reactants. Here we say number of moles of product are less than. Okay, here we say number of moles of products are less than number of moles of reactants. Right, here also number of moles of product are less than number of moles of reactants. Here we say number of product is equals to number of reactants. Now things will be easy for you. Right? Here what they are asking you, if you increase the pressure, increasing the pressure, it will go towards where number of moles are less. Okay? Increasing the pressure, it goes towards where number of moles are less. And number of moles are less in reactant side. So that means they are going to do backward reaction here. Okay? They are going to do backward reaction here. Yes? Now, if we increase the pressure here in the third case, in that case, it will, increasing the pressure, it goes towards number of moles where there are less number of moles. And number of moles are less in product side. And this is the product side, this is the reactant side. So that means it is going to do forward reaction. Okay, so the answer here is forward reaction. Now, if we are decreasing the pressure, what we will see, it is going to, everyone here, just opposite of this, if we say we are decreasing the pressure, right, just write it down, number of, it will go towards number of moles where we find number of moles are more. Okay, that means you can say inverse relation, it has inverse relation, right? So on decreasing the pressure, it will go towards where number of moles are more. Number of moles are more towards product, so it will do the forward reaction here. Here decreasing the pressure, it will go towards where number of moles are more. Number of moles are more towards reactant side. NR is more than NP. Right? So we will say it will go towards backward reaction. It is going to increase the, go towards the reactant side. Okay, that means backward reaction. If number of moles are equal, then there is no effect. Then there is no shift, no effect. Right? Okay, understood? Everyone understood or not? Is this clear to everyone now? Just remember this one thing, okay? Just remember this one thing for pressure. Right? For pressure, just remember this one thing. Now, next is effect of pressure, effect of volume. Pressure is inversely proportional to volume. So you don't need to remember anything here. Okay? You don't need to remember. This is a chart that I'll make you understand, but I'll teach you this chart, but you don't need to remember this. You don't need to cram anything here. Okay, effects will be opposite, right? Like we'll say for volume, okay, or I'll write it here only. I'll write it here only, okay, I'll write it here. I'll write it here. That you have, if you're talking about volume will say that is inversely proportional. Say if volume increases, it goes towards number of moles are more, okay, and if volume decreases, it goes towards number of moles less, where we have number of moles are less, right? That means we can say pressure is inversely proportional to volume. That is the reason, right? This is the conclusion of pressure and volume, okay? This is the conclusion of pressure and volume, right? Okay, yes. Now let us understand this one. Okay, so again this means number of product is more than number of reactants. Again, number of product is more than number of reactants. Number of product is less than number of reactants. Here number of product is less than number of reactants. Here number of product is equals to number of reactants. Right? Delta Ng means number of gaseous moles of product minus number of gaseous moles of reactants. So that way we have written this. Right? So now if you say you are decreasing the volume, it is going to go to less number of moles. Right? The less number of moles are in reactants. So that means it is going to have backward reaction. So the answer is going to be backward. In case we are increasing the pressure, increasing the volume means it is going to go in that direction where number of moles are more, right? So number of moles are more in product side, it is going to have forward reaction. Here decreasing the volume, more number of moles, less number of moles that are in product side, that means it is going to have the forward reaction, right? Increasing the volume, that means number of moles more, so that is in the reactant side, that means it is going to have backward reaction. If there is no change, there is delta Ng is equals to 0, number of products and reactants are same, gaseous moles are same, no effect, we are increasing, decreasing, anything, no effect on that. Yes everyone, any doubt till now? Any doubt bacha? Any doubt? Very important concept these are, okay? So next is effect of inert gas. Okay, what is the effect of inert gas? See, if you are adding the just let me erase this one. Okay, so if you are adding the inert gas, in case of volume there is going to be no effect. Okay, on adding the inert gas. Thank you, bacha. Thank you so much. Now I'll make ionic equilibrium a piece of cake for you. Right? Don't worry. So, effect of inert gas. If we say at constant volume, there is no effect. Okay, no effect. So just if we're increasing, decreasing, anything, no effect. If we have constant volume, inert gas addition has no effect on it. No effect on the equilibrium. Right? But if we are talking, I'll write it in my own handwriting. No effect here. Okay? No effect here. But if we talk about at constant pressure, okay, at constant pressure, if we say we have NP is more than NR, okay, that means we have products are more than reactants. In that case, reaction is going to shift in forward direction. Okay, if we say products are less than reactants, okay, reaction is going to shift in backward direction. Okay, if there is no effect, if there is no change in product, that is going to be zero, no effect. If there is no, the delta Ng is 0, if the number of gaseous moles of product and reactants are equal. So now ma'am, what does this mean? Okay ma'am, we want a simple conclusion to this. Okay, so if they are saying delta P is greater, okay, so in that it will, if products are more, you have reactants to products, right? So at constant pressure, you are adding the gas, the equilibrium is going towards that where number of moles are less, right? Okay, you can simply write it down here. Okay, you can simply write down here, wait. You can simply write down here adding inert gas, okay, adding inert gas. What will write? Adding inert gas, you have two things. First is, you have two things. First is, everyone, first is volume, constant volume. First is constant volume, it is having no effect. It is having no effect. Second is constant pressure. And if you are adding the inert gas, that is going to be going, reaction will proceed in less number of moles, which have less number of moles. Okay, it is going to proceed in that direction which have less number of moles. Now, if we say that products are more, in that case it is going to be it is going to, reaction will shift in forward direction. Sorry, more number of moles, let us write it here, more number of moles, okay, more number of moles, yes. Okay, so now if we say that products are more than reactants, okay, we have more products, these are reactants and these are products, right? So if the products are more, we'll say this is going to shift in forward direction where the number of moles are more, right? And also if we say reactants are more, okay, reactants are more, then in that case it is going to have backward direction, okay. So now next thing, bacha, I am going to conclude it, don't worry, I am going to conclude all the factors here after that, okay. Yes, okay. So now next is effect of temperature. For effect of temperature, what we are going to do, same thing that we did before. That in case of endothermic reaction, temperature is directly proportional to equilibrium constant, right? Temperature is directly proportional to equilibrium constant. If we are saying we are increasing the temperature, that means if I say T2 is more than T1, in that case K2 is also more than K1, right? K2 is also more than K1. That means it is going to have forward direction, okay, because K2 is more than K1, right? We are increasing the temperature, the new K2 is more than K1. That means it is going to be in the forward direction, okay? K2 is more, the equilibrium will shift in the forward direction, okay? Right? Understood? Because concentration of product is going to increase, right? K2, if the equilibrium constant is directly proportional to products. If the products are going to increase, that means concentration is going to increase. So simply you can write that when we increase the temperature in endothermic reaction, because they are directly proportional, K2 will be more than K1. That means product formation will be more. That means there will be more forward reaction. But in exothermic reaction, what we know that here temperature is inversely proportional to K. That means if we increase the temperature, T2 is more than T1, in that case K2 is less than K1. That means equilibrium constant is decreasing, and equilibrium constant is directly proportional to products divided by reactants, right? That means the value of product is decreasing. In that case, we will say that this is in backward direction, okay? This is in backward direction, right? And now if we say delta H is equals to 0, then there is no effect on by the temperature, right? Okay, yes, this is Van Hoff equation. Now, bacha, I am going to conclude all the things for you, whatever we have studied now. Not the whole equilibrium, but in Lee Chatelier principle, what we have studied, right? Okay, so everyone here, help me in this, okay? Do help me in this. Now, concentration, you know that it is going to behave in opposite manner. If you increase the concentration of anything, it will decrease it, okay? On increasing the concentration, it is going to decrease. Okay, I don't think so. You need to write it down in this chart, okay? I think writing concentration will be not beneficial here. Do you want me to write concentration also? Because concentration is the most simple thing here. You need to, cram pressure, temperature, volume, inert gas, all that are important for you. Right? Concentration is a very simple thing. But still, if you want, I can write it. Okay, if you want, I can write it. I will write here. Now, if you have, we're increasing the concentration of reactant. I'll just write one line here. The conclusion can be going to go in opposite direction. On concentration, just write it here, that equilibrium go in opposite direction of concentration. That means if we, no, I think no, this is not the right statement. Any idea what we can write here? Concentration we can write, if we increase the, what is the one line that we can use? Okay, try to write down one line here, because I like to conclude things, okay, because these charts are very important for your exam point of view. So otherwise I am writing for pressure. For pressure, what we are going to write here? For pressure, very simple thing, that is, for pressure just write one thing here, that we have on increasing the pressure, it is going to go in number of moles less. Okay, it is going to go in direction where number of moles are less. Right? On increasing the pressure, it is going to go in where number of moles are less. Right? And on decreasing the pressure, it is going to go in where number of moles are more. Where number of moles are more. Right? If we talk about volume, everyone, if we talk about volume, here what we are going to write? That in case of volume is pressure is inversely proportional to volume. That's it. Okay, that will be inverse of volume, right? That just you need to remember that. Next is on adding the inert gas. On adding the inert gas. On adding the inert gas, what we are going to write here? On adding the inert gas, we have two things, right? Volume, no effect. Volume, no effect, and pressure, if we talk about constant pressure, this is constant volume, right? So, in constant pressure, that is going to be in that direction where number of moles are more. Number of moles are more. Okay, what else we have? I think we have just these things, okay. We have one temperature here, right? Other part is temperature. Temperature, we have two things here. That is, everyone, we have two things here. Temperature, we have two parts, okay. Temperature directly proportional to pressure. Yes. So we have two parts here. Temperature, one is exothermic, other is endothermic, right? Simply I am going to write one thing here, that is, on increasing, I am talking about increasing, decreasing pressure, decreasing temperature will be opposite. Okay, in that case, on increasing the temperature, it is going to go in opposite. K2 will be less than, right? K2 will be less, that is going to be in backward direction. Okay, backward direction, right? Okay, and on increasing the temperature here, that is going to be in forward direction, right? Forward direction always, right? Okay, catalyst has no effect here. I'll write it here. Catalyst has no effect. Catalyst has no effect. No effect, it is going to increase or decrease the activation energy but not the equilibrium state, right? Okay, and what about the concentration? Concentration inversely proportional to volume. No, we cannot write that way, okay? Because, we cannot, write one single line on that, right? So, concentration, I will just write it here. It is going to behave in an opposite manner. If you increase the concentration of reactant, it will decrease. If you increase the concentration of product, it will decrease, right? It is going to oppose the change in concentration. right? Okay, it is going to oppose the change in concentration. Like if you increase the concentration, right? Okay, if you increase the concentration, everyone, like for example, I'm writing it here. For example, if you increase the reactant, it is going to decrease the reactants and going to be in backward direction. Going to be in backward direction, right? Okay? Yes, bacha, understood? Any problem now? Any problem here? We are talking about increasing temperature, decreasing temperature will be opposite. Is this clear to everyone? Is this chart clear to everyone here? Is this chart of Lee-Chatelier principle? You just need to remember all these things and all the questions from Lee-Chatelier principle will be solved. Yes, everyone? Any problem? Should we do the questions? Okay, let us do the question. Which one of the following conditions will favor maximum formation of product in the reaction? Maximum, okay? This is asked in 2018. 2018 question, that is, which of the following conditions will favor maximum formation of the product in the reaction? Maximum formation of product. Okay, first is low temperature. Okay, here see, we have to talk about temperature and pressure. Now, this is exothermic reaction. And this should favor the formation of product. That means it should be forward reaction, right? For forward reaction, in exothermic reaction, if you want to have forward reaction, you need to decrease the temperature. If you decrease the temperature, okay, T2 is less than T1. In that case, K2 is more than K1. Only in that case, we will have forward reaction, right? Okay. I just recall this one thing, that exothermic, when we increase the temperature, there is backward reaction. So when we decrease the temperature, there would be forward direction, right? So that's it. And the reason is this one, okay? For, to increase your speed, you just need to remember these things, right? Okay. Next is low temperature, and this cannot be the answer, right? This cannot be the answer. So, for that, this will be high pressure or low pressure. Number of moles, gaseous moles are, these are products. Number of moles of gaseous products is equals to 1 and gaseous reactant is equals to 2. Right? So, number of moles of gaseous product are less than gaseous reactants. Right? Product are less than gaseous reactants. So, in that case, we know that we have to increase the product formation. That means we have to convert into less number of moles. So pressure, when we increase the pressure, that go to less number of moles, right? So that will be high pressure. You can see this here. If we increase the pressure, that is number of moles less, right? So the answer will be low temperature and high pressure, right? Okay, yes. Now, next thing here is, for a reversible reaction, if we talk about a reversible reaction, here we have the equilibrium constant, same reactions, okay, same kind of question, 2014 question. By increasing the concentration of NH3, everyone, by increasing the concentration of NH3, everyone here, for a reversible reaction, what is the answer? For forward reaction. For forward reaction, this is an exothermic process, right? Okay, you're increasing the concentration of NH3. If you increase this will be in backward direction. Because you are increasing the concentration of products. It wants to go backwards then. It wants to decrease the concentration of products. Oppose this. So it will be backward reaction. So this cannot be the right answer. Right? By decreasing the pressure, if we decrease the pressure, decreasing the pressure means it is going to go towards number of moles, where number of moles are more. Number of moles are more in this part, that is 3, 4. So that is also going to be backward direction. Right? This is also not true. Right? Okay. So this is wrong. This is wrong. Right? Okay. This is also in backward direction. Also in backward direction. Right? I don't know why I have this OCD of blackboard. So by decreasing the concentration of N2 and H2, right? If we decrease the concentration of N2 and H2, that is going to increase the concentration of reactants. So that is also going to be in backward direction. Again backward direction. By increasing pressure and decreasing temperature. If you increase the pressure, that is going to be less number of moles. Less number of moles are here, that is forward direction. Right? Less number of moles. Less number of moles, that is forward direction. Right? And decreasing temperature of exothermic also forward direction. This is also forward direction. Right? So answer is going to be D here. Right? Okay? Very good. Very good. Now, bacha, let us talk about the crash course, and after that I am going to give you break. Okay? So how you can enroll to the crash course? Everybody, those who are preparing for NEET 2024, all the droppers, you can just go through this one, okay, the link in the description, and here you will see this crash course, right? And this crash course is just for 4,000 for 2 months, I would say now. Like you have just 2 months left, but now it has been 1 month that this crash course is starting, right? That this crash course has started. Now, what you can see, you can watch the recorded videos here, right? That are in the past, and now you can solve in the live sessions, you will see all the chapters, all the doubt sessions, and series, test series, mock test series, everything will be provided to you in this crash course. Okay, and I feel that this is a very like minimal amount for your destiny, right? Okay, this is a minimal amount for that, right? So just enroll to this, right? And then you can just go through this, and there will be a buy now option, right? Okay, now you can do the payment, right? This is a very simple process, right? So, and one more thing, that is treasure box. Okay, I always, do you even go through the treasure box and solve the PYQs? Do you even go through that? Yes, bacha, I am going to give you break time now. Okay, do you go through the PYQs or not? Do you study NCERT questions, solve those NCERT questions, PYQs or not? Because that is why I show you daily. Now this is free of cost, okay? This is free of cost. This PYQs test, this is CBSE, this is NEET, this is CBSE NCERT questions. All these are free of cost, okay? And the PYQ test for equilibrium is in this, okay? After today's lecture, after I complete ionic equilibrium, you need to go there and give your test here, okay? Very simple. You have just, it will take you, I guess, around 20 minutes to solve this test, okay? Now, next thing is NCERT solutions. If you are so lazy to go through the treasure box and find the links, you can just go through it, okay? If you are talking about this equilibrium, the links are in the description for everything, right? Okay? So these are the PYQ tests, this is NCERT solution, these are equilibrium notes will be updated after the session, right? Okay, everyone? Yes, beta? Now, I am going to give you break. Now, bacha, and all the students who are asking that, ma'am, is this in English or Hindi? This is in English. Okay, this course is in English, right? So now we have break time. Okay, I'll also have my lunch. You also have your lunch, because after that the session is going to be long. We are going to cover ionic equilibrium now after that. Okay. Yes, and I promise you that I will make ionic equilibrium very easy for you. Very easy. Right? Okay? Yes, everyone. Yes, bacha, definitely you can watch my lectures. Okay? You can definitely watch my lectures. Yes, bacha? Okay. So, I am now giving you timer of, I think, 20 minutes which will take me to have dinner. Right? 20 minutes is fine. Okay? 20 minutes is fine. Don't worry, fever. If you have fever, just have some medicine and take rest. Watch my lectures and go through the notes and take rest in between. Yes, don't worry. A fever will not stop us. But now also, when I say this, also take care of your health. Take proper medicines and healthy foods. Okay? Do not put your health aside when you are preparing for NEET. Right? That is very important, because health is everything. Right? Okay, so now where is the timer? I am going to give you 20 minutes, have your lunch, and after that we will start with ionic equilibrium. See you all after the break. Okay, so hi everyone, I am back. Everyone, I had my lunch. So did you also had your lunch? Everyone, you guys alive? Yes, we are alive. Yes, we are not live, we are alive. Okay. So now everyone do join in. Everyone in the comment section. Now we are going to start ionic equilibrium. So let us also call the students. Let us give the information on Telegram channel. Right? Let us give the information on Telegram channel. Equilibrium. Okay. I think students are eating or what? Guys, I am not able to see your chats. Okay? I am not able to see your chats. So if you don't respond, how can I start the session? Waiting for your replies now. I'll be standing here. You also not responding. I will also not respond. Right? I'm also standing here still. Yes. Hello, Bacha. Hello, Sharath. Hello, Yashwant. Yes. Yes. Now I can see your chat. Now I can see your chat. Now it seems like yes, you guys are like active. But otherwise it was like you guys are sleeping or what? Now everyone had your lunch or not? Everyone, I had my lunch. All of you had your lunch or not? Yes. Again back with the same energy. Shall we start? No, I am ready. Perfect, perfect. Okay. So now we are going to start. Welcome back. Thank you, thank you. You also welcome back. Now we are going to start ionic equilibrium, right? Students are very scared of this. Ionic equilibrium. Now we are going to start this. Okay? Ionic equilibrium. Equilibrium. Okay? So let us start ionic equilibrium. Starting with the concepts of acids and bases. Starting with the concept of acid and bases. But the first thing that we have is Arrhenius concept. In Arrhenius concept, it was stated that if you have an acid, and that acid, okay, what is an acid and what is a base? According to Arrhenius, an acid is that which on dissolution with water, when we dissolve that acid in water, it give off H positive ion. That is an acid. And a base is that which on dissolution with water gives off OH negative ion. Okay, that is a base. Okay, that is the Arrhenius concept. Now, what is modified Arrhenius concept? Modified Arrhenius concept is that if you're talking about an acid, okay, let's say He, and we're dissolving this in H2O, it is going to give us H3O positive plus A negative. He's not saying that it is going to give us H positive, because Arrhenius states that on dissolving acid in H2O, and we know acid gives H positive, that it gives H positive. So together H positive and H2O together forms hydronium ion. Okay. So instead of writing H positive, the modern Arrhenius concept says that it gives off hydronium ion. Okay. Hydronium ion. In some books and in some equation, you will write H positive. Okay, you will see H positive. Somewhere you will see hydronium ion. Hydronium ion and H positive are same only. Okay, we can replace one with the other. Okay, we can replace one with the other. Yes, even I am scared of ionic equilibrium. Don't worry. After this class, I'll ask you if you are scared or not. Okay? Yes. Yes, it will take time. Okay, you will take the class. After that, you will revise that. You will solve the questions. That will be easy for you after that. Okay? Yes, but today I am going to clear your concepts. Okay, bacha? Yes. Now, next thing is Bronsted-Lowry concept. Wait, where is Bronsted-Lowry concept? Oh. No, I think it's not added. We have not. Okay, there is Bronsted-Lowry concept. Wait. Okay, just give me a minute. I will erase this thing. Okay, what is Bronsted-Lowry concept, everyone? What is Bronsted-Lowry concept? You know what? In Arrhenius concept, we know that the acids is going to give off H positive and the bases are going to give OH negative. But if we talk about NH3, it does not have any OH negative ions. Now, how can we say that this is a base? How can we say? So for that, Bronsted-Lowry proposed another concept, that is Bronsted-Lowry concept, where it states that acids are those which gives H positive and bases are those which accepts H positive. Okay, like we say NH3, why this is a base? Because it is accepting H positive from the acid and it is giving off the H positive, so it is making NH4 positive and this is OH negative. Right? So according to Arrhenius, acid is that which gives H positive, or we can say hydronium ion, and base is that which gives OH negative. According to Bronsted-Lowry concept, acid is that which gives H positive, which gives H positive, that is a proton donor, and base is that which accepts H positive, that is a proton acceptor. That is Bronsted-Lowry concept. Now, talking about Bronsted-Lowry concept, we have another very important concept of conjugate base and acid. Conjugate base and acid. So everyone here, what is the concept for conjugate base and acid? See, always, for example, I am talking about a acid. Let's say I am talking about H2SO4. Okay, acid gives off H positive, right? According to Bronsted-Lowry, this gives H positive and it is going to form SO4 to HSO4 negative. Now, this is the acid, okay? This is the acid and the base corresponding to this acid, okay? After giving H positive, the thing that is left is called conjugate base. Because why this is base? Because this is going to accept this H positive and become H2SO4 again. This is acid, this is conjugate base. And always, if you have strong acid, that is going to give weak conjugate base. If you have weak acid, this is going to give strong conjugate base. These are opposite to each other. If one is strong, this will be weak. If this is weak, this will be strong. Right? Okay? This is opposite to each other. Now, next question that is asked to you about this, that for example, out of which of the following is a pair of conjugate acids or conjugate base and acid? Right? For example, you have H2SO4 and SO4 2 negative. Are these pair? And H2SO4 and HSO4 negative. Right? So you have two questions here. This is one, this is B. Now tell me, which is a pair of conjugate acid and base? From A and B, which of the following is a pair of acid and base? Yes, bacha, which is the pair? Which is the pair? If we talk about this acid, okay, this is the acid. Now, if we see, there is difference of 2 H positive here, okay, and here we see it is a difference of only 1 H positive. So this is not going to be the conjugate acid base pair and this is going to be the acid conjugate base pair, right? Yes, very good. Why? Because you can write acid and its conjugate base, and its conjugate base has difference of only one H positive. Right? Or you can also write it as base and its conjugate base. For example, that you have this thing, that you have NH3 is going to accept H positive and form NH4 H positive, NH4 positive, right? So now this is the base and this is going to be a conjugate acid. So these also, this conjugate, this also has a difference of one H positive. So there will always be difference of just one H positive in this. Yes, bacha, difference of one H positive. Right. Now, bacha, next we have Lewis acids and Lewis bases. So Lewis acids are those which are electron deficient. These are electron deficient. So these are electron deficient. And Lewis bases are electron rich. Okay, these are electron rich. Things that are electron deficient, they are called Lewis acid. Which is, for example, you have this. Okay, this is actually an acid because it does not have complete octet. So that is why it is a Lewis acid. It is electron deficient, right? So it has lone pair of electron. That is why it is electron rich, and that is why it is a base, right? Okay. So this was about acid and bases. Now let us do some questions on that. Conjugate base for Bronsted acid. They are saying conjugate bases from this and this. Okay, what are the conjugate bases? So here lose H positive, it will give OH negative. After losing H positive, it is going to give F negative. So answer is going to be D. That is OH negative and F negative respectively are the conjugate bases of these acids. Right? This is asked in 2019. See, very simple question is asked, right? Okay. Next, bacha, next is Ostwald dilution law. Next is Ostwald dilution law. So now what does Ostwald states? Ostwald states that when we have a, so now before that we should know what is a strong electrolyte and what is a weak electrolyte. What is a strong acid, what is a weak acid. For example, I am talking about HCl. This is a strong acid. Why? Because it has 100% dissociation. It has 100% dissociation. And when we are talking about a weak acid like CH3COH is a weak acid, right? This is having partial dissociation. Okay, this is partially dissociated. This is partially dissociated. Okay, this is partially dissociated. Yes, bacha. Okay, this is partially dissociated. That's why what we write here, CH3COOH. And this is going to be CH3COO negative plus H positive. That means this is not 100% dissociated. If you have 100 molecules of CH3COH, maybe out of that 70 molecules are dissociated and 30 molecules are undissociated. But in case of HCl, all the 100 molecules will be dissociated, converted into give off the H positive ions. Right? That is the difference between strong acid, weak acid, or we can say strong electrolyte and weak electrolyte. Now, Ostwald dilution law states that if you have a strong electrolyte, right, that will be 100% dissociated. But if you have a weak electrolyte, that weak electrolyte, when you dilute it, okay, you have a weak electrolyte, say you have CH3COH, right, you are adding water to it, right? When you are diluting it, they are saying add infinite dilution, it is going to behave as strong electrolyte. Okay, what does Ostwald dilution law state? That at infinite dilution, when you have infinite dilution, this weak electrolyte, this weak acid is going to behave as strong acid. That means this weak acid is going to have 100% dissociation at infinite dilution. Okay, this is what is the meaning of Ostwald dilution law. And all these things we are going to do. Okay, we are going to derive this. Don't worry. Now, this is the concentration. We are diluting it. That means we are decreasing the concentration. So when we are decreasing the concentration, the degree of dissociation is increasing, and at infinite dilution, when the concentration is 0, okay, at that point weak electrolyte has alpha is equals to 1. That means alpha percent is equals to 100% dissociated. Now weak electrolyte will behave as a strong electrolyte. Yes, this is in electrochemistry as well, right? This is in electrochemistry as well. Very good, Sharat. Now, next is, let us derive this dissociation of weak acid. Firstly, that we are going to do is dissociation of weak acid. Okay. Weak acid, let us assume one weak acid, that is acetic acid, CH3COH. Okay. Very simple. You find this very simple. CH3COO negative plus H positive. So now there is one rule of equilibrium. Okay. One rule of equilibrium that you must know. All the derivation is going to be very easy for you. Right. This is a weak acid. There is partial dissociation. Initially, before equilibrium, you have, this is the concentration C of acetic acid, right? This is having zero concentration. Now we know that 100% is not dissociated. We cannot say this whole C concentration is dissociated here, right? Some of it is dissociated. They are saying it is giving us, let us say, okay, let us see if this is 1, okay? Let's assume this is, okay. Let us assume, for example, the degree of dissociation is alpha. Okay, alpha is the degree of dissociation. Okay, if I say alpha is the degree of dissociation, that means out of this concentration, alpha will be dissociated here, right? If I say 70% is the degree of dissociation, and I have 100 molecule, what I will write? 70% of this 100 molecule is going to dissociate. That means I am going to multiply, this is 100, this is going to be alpha. So I am going to multiply alpha with this C. That will be the number of H positive ions produced. So I am going to write here that at equilibrium, I will have C alpha amount of H positive ion. If here, if for example we have any acid that is giving us 2H positive, here we will write 2C alpha, okay? That we will write 2C alpha. Here we are writing C alpha, right? And if this is C alpha, if one molecule is giving one CH3CO negative and one H positive, this is C alpha, this is also going to be C alpha. And how much of this will be subtracted? C minus C alpha. Now ma'am, why I have not written C? Bachcha, see this. If you have 100 and out of that 70 are dissociating, that means you have 70 H positive, you have 70 E negative, right? And this 30 molecules are HAO because they are not associated. In that case, what you will write that out of these 30, you will have minus 70. You will not write that this is 70, this is 70. You will subtract 140 out of that because one molecule is giving you one CH3CO negative and one H positive. That is why here we write this much, okay? C minus C alpha, right? Okay, if here we have 2H positive and here we have 2C alpha, in that case also we will subtract 1C alpha because one molecule is dissociated, one molecule is giving 2H positive, right? Understood, bacha? Because one molecule is giving one this, okay? Okay, bacha? Understood? Understood, bacha? Is this clear to everyone here? Is this clear to you? Yes, because this point is very important. For example, I am writing it here. For example, they have given you HNA, right? That means it is going to give us A negative plus NH positive. In that case, what you will write, this is C, this is 0, this is 0, and this is going to be C, and this is going to be C, this is going to be NC alpha, this is going to be C alpha, and this is C minus C alpha. And the equilibrium constant is going to be Ka, is going to be, that is the dissociation constant here is going to be product by reactant, that is C alpha, right? NC alpha raised to the power n divided by C 1 by alpha, 1 minus alpha. Everyone understood this? This is your what if 2 molecules? Yes, just put 2 here, okay? If you put 2 here, this will be, if you put n is equals to 2, that will be C alpha, and this is 2 alpha, 2C alpha, 2C alpha square divided by C1 minus alpha. Okay? Understood this? Yes, bacha? Okay. Bacha, see this. You have n. If you have n amount of, if you have n H positive that are dissociated from one molecule. You have one molecule, there are n number of H positive that is dissociated, right? So here H positive is going to be NC alpha, okay? That is going to be NC alpha. But in case when we are subtracting this, we are taking NC alpha and we are taking n amount of H positive from just one molecule. So we'll subtract C minus C alpha and the general equation is going to be this. Yes, bacha? Yes, bacha, don't give importance to these kids because they are going to ruin our lecture, okay? Ruin our lecture. So do not give importance to these kids. So they are just useless people who are here, right? So let us focus on our exam because we have our exam in 2 months. Those kids who are actually serious, no, they don't, before 2 months, they are not here for hate comments and all that. Those kids, even if they are not studying from me, who are serious for their studies, they are somewhere studying. They are doing self-study or some studying from some other channel or some other teacher. They are studying only. These are not even students because students are focused on like whatever they feel that okay, this is the good content. I'm able to understand this and they will learn. They don't care about all these things. Okay, students don't care about all these things, right? Okay, bacha. Yes, this is the general thing. Now, if I talk about usually, this case is very less. They will ask you this question. This case is very less that they will ask you this one because this is kind of twisting thing, but they can all ask you, right? If they ask you this one, you will be able to answer this, right? If they give you 2H positive, the answer will be 2 and 2 here. Okay, I have written the general formula here, right? Okay, everyone. Yes. Okay. Now, bacha, let us see. This is going to be Ka is going to be, this is products C alpha by reactants. Reactant is C minus C alpha. Okay, now derive this equation, everyone. Derive this equation. This is going to be C square alpha square. C common 1 minus alpha and this is going to be C. This is going to be C alpha square 1 minus alpha. Now see, for weak acids, this degree of dissociation is very less than 1. This is so small because there is very less dissociation. So in that case, this alpha is so small that in comparison to 1, we can ignore it. Okay, so here we can write C alpha square. Yes, bacha. Okay, so for acetic acid, usually they will give you acetic acid only. Okay, so this equation is going to be, everyone. So the equation is going to be, I'm writing it here. Okay, all the formulas for weak acids, I'm writing it here. So this is going to be Ka equals to C alpha square, right? This is going to be C alpha square. Yes, everyone, this is going to be C alpha square. If you know what is C alpha, this is H positive. So we can also say this, that if I multiply this with C, this will be C square alpha square. Right? What is C alpha? C alpha is nothing but H positive here. Right? So write it H positive. This is H positive square. This is C Ka. Okay? So H positive is going to be under root C Ka. Yes, everyone. This is going to be your second formula. This is going to be your second formula. This is going to be your first formula. We have derived it from this one only. Yes, bacha. Any problem till now? Any problem till now? So from this formula, we can also derive 2-3 more things here. Okay. So let us see what all we can derive from this. Yes. So we can also write here that if we have two acids, and if those two acids, for example, this is giving us H positive 1, this is H positive 2. Okay, this is H positive 2. Now, this is going to give us, under root C1 Ka1 divided by C2 Ka2. Okay, this is the dissociation constant. Okay, this is Ka1 Ka2. For two acids, if the concentration is different, the dissociation is different. The ratio is going to be this one. Okay, let us write one more formula for this that we can derive from this one. That is, everyone, if you have same concentrations, so from this what we can say, if we write C1 is equals to C2, if C1 is equals to C2, in that case we can write H positive of 1, or I can write it by some other marker, that is H positive 1 by H positive of 2 equals to under root Ka1 divided by Ka2. Yes everyone? Yes bachcho? Everyone? Okay bachcho? Understood this? Yes? Okay? So this is going to be just from one formula. We have derived till now 1, 2, 3, 4 formulas. Okay, we have derived 4 formulas just from one formula. Right everyone? Okay. So next is how you are going to calculate pH. Okay, how you are going to calculate pH, very important formula. pH is equals to half of log Ka minus log C. Okay, this is going to be a formula for calculating the pH of a weak acid. They will give you some hints to calculate Ka, and they will give you the concentration, the initial concentration of the acid, right? This is the initial concentration of the acid. This is Ka, this is the dissociation constant, and you will calculate the value of pH here. Okay everyone, you will calculate the value of pH here. Understood? Any problem? Any problem till now? One more thing also, one more thing here, one more thing, because I want you guys to just, the most difficult part of equilibrium is, like Lee Chatelier principle, what we did, we combined all the things in just one page. This is my task, that I'll combine all the things in one task. This all the formulas for weak acid I have written here, right? So you just need to go through that page and you just need to put the formulas, because the numericals are easy, but recalling the formulas, that which formula to apply where, that is the tough part in ionic equilibrium, right? Okay, so pH is equals to half log Ka minus log C. So now pH is equals to, now what is log Ka? What is log Ka? Always remember, I am writing it here also. Always remember this one thing. I'll write it somewhere else, okay? I'll write it somewhere else. So this is pKa equals to minus log Ka, right? This is equals to minus log Ka. Wait. Yes. This is pKa, okay? This is pKa. This is pKa, not log Ka. This is pKa. Okay? This is pK. Okay? This is pK minus log C, and pK is equals to minus log C. Whenever you have to calculate the value of P, okay? Whenever you have to calculate the value of P, any value is equals to minus log base 10 of that value. Okay? Any value. If you are calculating any value here, okay? Any value here. For example, if you are talking about log Ka, that is equals to minus log base 10 Ka. If you are talking about log this is pKa, okay? If you are talking about pH, this will be equals to minus log H positive concentration. If you talk about POH, that will be equals to minus log OH negative concentration. Now, if you talk about anything, okay? If you talk about PKW, that is equals to minus log of KW, right? Okay? All the formulas are like this, okay? Any value here, P of any value is equals to log base 10 any value. Right? Okay? Yes, bacha? Okay. Now, let us do the next thing, that is this is pKa. They will give you the values of pK. pK is inversely proportional to, okay? It is inversely. It is minus log of Ka. That means it is inversely proportional to Ka. And Ka is directly proportional to the acidity. Okay, that is directly proportional to the acidity. So these are the most important things from weak acids. Okay, these are the most important things from weak acids. Any doubt, bacha? Any doubt from weak acids? Any doubt from weak acids? Now I am going to form the same chart, similar chart for weak bases. Okay, same chart for weak bases. Okay, let us form the chart. Okay, let us just copy this, and the formulas are completely same. Okay, the formulas are same. Okay, let us write it down. This is Kb. This should be Kb. This is C. This is Kb. Right. This is also Kb. This will be OH negative, and this is also Kb. Right. Okay. So let us write it here. This is Kb. Right. This is also Kb. This is Kb. This is OH negative. Right. Everything is same. Okay. Everything is same here. This is OH negative. Right. OH negative square. And this is going to be OH negative. Right. Okay, everyone. This is OH negative. Right. Next thing is, this is the, I'll write down it. Okay, I'll write it down. So this is going to be OH negative of 1 divided by OH negative of 2 equals to under root C1 Kb1 divided by C2 Kb2. Right? Okay, same as that. Same as weak acids. We are making the formulas for weak bases. Okay, same kind of formulas. So here in place of OH positive, I am going to write OH negative. So this will be OH negative divided by 1. Okay, this will be OH negative 2 equals to under root Kb1 divided by Kb2. If the value of C1 is equals to C2, where alpha is, okay, here alpha is the degree of dissociation for weak base, right? And there alpha is the degree of dissociation for weak acids, right? Okay. Now, what is the value of POH? Okay, this is going to be pKb, and we can write here. This is POH. This is POH, right? Okay, and the value here will be. This will be. Everyone, this is P. Kb equals to minus log of Kb, right? You can also write one more formula here. You can also write one more formula that I am writing here. That you can also write that you have pH plus POH equals to 40. Okay? So how you will calculate the pH here? First you calculate the POH and then apply the formula here. You will get the value of pH also. Right? Any problem? Same kind. Yes, same kind. I also derived that. Firstly, let's write the formula. I will also derive this formula for you. Okay? I will also derive this. And you know what? How you got this formula? Now everyone will be so skeptical that, ma'am, you have written these formula. This is derived from this formula. This is derived from this formula. Ma'am, but now this formula, where you have derived this formula from? But this formula is nothing but this is the log of this formula. Okay? See. You have H positive, okay, H positive equals to C under root C Ka, right? If you take the log of this, okay, if you take the log of this will log H positive, this will be half, because this under root is nothing but half, right? Okay, just take the log of this, constant will be here, right? This is log base 10. This is C plus log Ka, right? Okay. Now multiply the whole term by minus. Okay, this will be minus log H positive. This is minus, or you can write here half. You have minus log C. This is going to be minus log Ka, right? If you don't know how to, cram the formulas, that way you can just write it down how you have derived it. For example, you forgot that formula in the exam. So now what is the way? Right? This is the way how you will derive the formula. right? Okay, otherwise derivation is not asked in your exams. Okay, this is in NEET exam. pH is equals, this is a pH, this is equals to half, this is minus log C, and this is pKa. Okay, so from just one formula, okay, we have derived all these values from just one formula, right? We have, okay bacha, we have derived all these values from just one formula. I think I need to block someone because I don't want any disturbance in my class. Okay, so bacha, this is the first equation that we have derived. We have derived this one equation that K is equals to C alpha square, right? From that we have derived this equation, right? H positive is equals to this, right? After that we have derived this equation from this equation, right? Okay, so just one formula we have derived all the equations, right? And these are the set of equations. Yes bacha, and these are the set of equations. Any problem beta? Any problem? Now I think this is dissociation, these are the formulas, and this is the derivation of that formula. I'm not able to see your chats because of some guy who is disturbing us. Let us block that person, right? Okay. Okay, now bacha, everybody in the chat box understood this? All the formulas for weak acids. Now ma'am, how you can say these are the same formula for weak bases also? Okay, for weak bases, let us talk about weak bases. If you talk about weak bases, okay, same is the case with weak bases. For example, you have MOH. You have MOH that is dissociated into M positive plus OH negative, right? Okay, so in that case, what I am going to write, firstly it will have initially C, this is 0, this is 0. This is the initial concentration when there is no product formation. But after, at equilibrium, what we are going to have? At equilibrium, we are going to have alpha amount of OH negative, and that is C alpha amount of, alpha is the degree of dissociation, right? C alpha amount of OH negative. And now here we are going to have, this is going to be C alpha only, this is going to be C minus C alpha. Similar way, you are going to calculate the value of Kb, that is equals to C square alpha square. C1 minus alpha, that is going to be C alpha square, okay? Because this alpha will be ignored here, that will be C alpha square, okay? That is why same formulas are for Kb, right? Same kind of formulas are for Kb. But now if you say that, wait, let me generalize this formula. The general formula should be here, okay? I am just making your notes easy for you. Right? So this is the general formula. This is the general formula, right? Let us write the general formula for this. Let us write the general formula for MOH, right? This is M. For example, you have M OH N, or you can write here A, or I'll write just one thing, M OH. This is A, this is B. Okay. Okay. Let us do one trick here also. If this H is, if you have this H is actually, if this is giving us n amount of H positive, or you can write here, this is H, this is let us write M only, okay? Let us write M only. If this is giving us M amount of, if this is giving us M amount, this is the symbols, okay? If this is giving us A amount of H positive and B amount of M negative, okay? So I'll write here, this is B amount of M negative and A amount of H positive. In that case, I can write, this is BC alpha and this is AC alpha. In that case, this will be C alpha only. So the answer is going to be Ka, general formula is going to be BC alpha, raised to the power b AC alpha raised to the power a divided by C1 minus alpha. Okay, this is the general formula. Everyone, this note is very useful and this one is also very useful. Are you able to understand this thing? That if something is giving you B amount of any amount of A negative or M negative, the negative part, the anionic part, this is the H positive, A amount of H positive. So we are going to write AC alpha, right? This is going to be BC alpha. Okay? And this is just from one molecule, so one molecule will be subtracted from here. Right? So C minus C alpha. Yes, everyone? Okay. Now, let us write it down for weak base. Let us write it down for weak base. So, this will give us M amount of M positive, that is Ma positive, plus B amount of OH negative. Right? So, here what we will write, this is C0, 0. And after that, this will be AC alpha. This is going to be BC alpha. This is going to be C minus C alpha at equilibrium. Okay, this is at equilibrium. If you have any doubt in this, please ask me. Okay, if you have any doubt in this is going to be KB is equals to AC alpha A BC alpha raised to power B divided by C1 minus alpha. This is a very rare case that they will ask you this kind of question. Okay, but this kind of question they will surely ask you. This question they will surely ask you, where you will have to cram all these formulas. Okay, this they will surely ask you. Okay, yes everyone, any doubt? Any doubt till now? Any doubt, bachcho? This is for weak base, we have already done this. Okay, yes. No doubt? Okay? Okay, perfect. Now let us do the percentage of pyridine. Percentage of pyridine that forms pyridinium ion in 0.10 molar aqueous pyridine. Okay, you have pyridine, that is pyridine you have, this forms pyridinium ion. Okay, it is going to accept H positive and form PYH positive. This is the pyridinium ion in 0.1 aqueous solution pyridine. Okay, the aqueous solution here is 0.1. Okay, 0.10 aqueous solution, right? So they are asking you the degree of dissociation. They are asking the percentage of pyridine that forms pyridinium ion. That means they are asking you how much pyridine is accepting H positive. Pyridine is a base, right? So how much pyridine is accepting H positive? That means they are asking you the alpha. Percentage means they are asking you the alpha percentage. Okay, they have given you the value of C here. They have given you the value of C. They have given you the value of KB. They are asking you the value of alpha. Okay, so KB is equals to C alpha square, right? Okay, that means alpha is equals to everyone. Alpha is equals to C alpha square. Alpha is equals to KB by C under root, right? Alpha is equals to KB by C under root, right? That's it. You just have to put the values of KB and C here and you will get your answer. Okay, and you will get your answer from here. So just put the values here and you will get the answer here. Okay, just put the value of C, apply this formula. KB is equals to C alpha square. So this is asked in 2015. Okay, very simple question is asked. Now let us do the pH scale. Next part is the pH scale. So pH scale is what? We know that pH is equals to minus log pH positive. H positive. Concentration of H positive. Right. Okay. So now that means more is the concentration of H positive, lesser will be the pH value. Right. So here we have written for acidic solution, H positive is greater than at 10 raised to power minus 7. Okay, 10 raised to power minus 7 if you put here, that will be, if you put the value of pH is equals to minus log 10 raised to power minus 7, that will be minus of minus 7, that will be log base 10 1. This is going to be 1, log base 10 of 10 is going to be 1. So this is going to be 7. Okay. So they are saying that if pH, if the concentration is equals to 10 raised to power minus 7, in that case pH is going to be 7, right? In that case pH is going to be 7, right? So that means if we say the concentration is more than 10 raised to power minus 7, that means the pH will be less than 7. Okay, because we know that pH is going to be less than 7, because from this formula we know that pH is inversely proportional to H positive, because it is equals to minus log of H positive. Okay, when we say pH is equals to minus any value here, we say any value here is equals to minus log of any value here, same value here. So this value is inversely proportional to this value. This pH is inversely proportional to this H positive here, right? Okay, same with the value for, same is for POH, right? Same is for POH. If you write POH here, POH with concentration, the concentration of OH negative is 10 raised to power minus 7. POH is going to be, POH here is going to be 7. Okay, that means we can say if H or OH negative is less than 10 raised to power minus 7, right? Or we can say H positive, because OH negative and H positive are opposite to each other. If OH negative is less than 10 raised to power minus 7, then H positive will be greater than 10 raised to power minus 7. In that case, we can say if OH negative is less than 10 raised to power minus 7, that means POH is going to be more than 7, right? Okay. Yes, bachcho, understood this? Or we can also write here that if, if OH negative is more than 10 raised to power minus 7, in that case POH is going to be less than 7, right? That means pH is going to be more than 7. Okay, bachcho, understood? That means pH is going to be more than 7. Now, how you derived all this? Please conclude this part. So this part will be concluded as pH is inversely proportional to H positive. POH is inversely proportional to OH negative, and H positive and OH negative are inversely proportional to each other. Okay, H positive and OH negative are inversely proportional to each other, right? And the formulas from where we have derived these three concepts are derived from pH is equals to minus log of H positive, POH is equals to minus log of OH negative, and this is derived from this one, that H positive, or you can write here, you can also write two formulas here, that is H positive, OH negative equals to 10 raised to power minus 14. We will derive these two formulas, okay? pH plus POH equals to 14. Okay, so these are the important formulas. Okay, these are the 4 important formulas from where these things are derived. Yes, bachcho. Okay, so this is the pH value scale where you can see more the acidic. Okay, lesser is the pH, more is the acidic value, more is the pH, more is the basic value. Okay, yes, that is, this chart is derived from this particular formulas only. Right, everyone? Okay, understood? Any problem? Yes, these formula charts are useful. Yes, these are going to be very useful for you. Okay, very useful for you. This is how you learn, right? This is how physical chemistry should be done, right? Okay. Yes. Next is ionic product. Okay. Let us talk about the ionic product, that is KW. Now, what is KW? Let us understand that, ma'am. We don't want to cram anything. I don't want you to cram anything. Okay, either. So let us derive this. You have H2O, right? Okay. So H2O, what it is going to give us? H2O plus H2O, okay, this is going to give us H3O positive plus OH negative, right? Okay, it is going to give us this. Recently I saw a meme on this, and how water and water can give this, right? Okay, so we have H, this is hydronium ion, this is the hydroxide ion, right? Okay, so let us find the equilibrium constant here. That will be equals to products, that is H3O positive, OH negative, right? Okay, divided by this water. Okay, this is the water. Okay, you can also see this one thing, or either they can write this thing or they can write this thing. Okay, or they can also write it like this. Okay, they can also write it like this. Water gives off H positive and OH negative. For that, what you will write, both are correct. Okay, both are correct. Nothing is wrong here. For that, we will write H positive, OH negative, right? And here we will write water, right? Okay, both are correct. Okay, in some books you will find that, in some books you will find this. Okay, both are correct. So now just multiply this here, K equilibrium into water equals to H positive plus OH negative. Right? Okay, so now why I have written it here? Why? See, water is written here to generate a new equilibrium constant, right? So you will say, ma'am, how? Does anybody have this question in their mind? That, ma'am, you are saying this water is constant, and only constant and constant multiplied to each other can give off new constant, right? So I am saying this is also constant, right? I am saying that these both are constant, that this is also constant and this is also constant. So why I am saying this water is constant? I am dissociating the water. That means water is decreasing. You know what happens with water? It has very less dissociation constant, right? It has very less dissociation power. Only in thousands, only just one molecule dissociates. Just one molecule dissociates. That is the reason what we write here, that this water is, the concentration of water is not changing. Because in thousands, only one molecule is getting dissociated. Right? That is why we say this is also a constant, and hence we will have a new constant here. And what is that new constant? Everybody in the comment section, what is that new constant? Okay, what is the value of that new constant? The value of that new constant is, that is Kw, that is Kw. What is the value of that new constant? That is Kw equals to H positive and OH negative. Right? Okay, Kw is equals to H positive and, ma'am, how and water? Beta, these are actually not macroscopic things. Okay, these are microscopic things. Right? So also they need some initiation. Right? Some initiation. But if we say this 2 water is giving off H, because this water is getting dissociated. Right? This is giving one H positive, one OH negative. Right? So by some initiation process, it is giving H positive and OH negative. Right? This is how water and water are giving H positive and OH negative. Right? Okay? Yes. Now, let us see this. What can be the values of Kw? What can be the different values of Kw? Any idea, bachcho? What can be the different values of Kw? Kw have different values. If we say, always remember this, on increasing the temperature, Kw increases. That means this is a kind of, what kind of process this is? This is a kind of endothermic process, right? Okay. This is a kind of endothermic process. That is why on increasing the temperature, Kw is increasing, right? Okay. It is absorbing some energy. It is absorbing the energy, right? Okay. So this is giving, okay, you just told that me, yeah, that has millions of views on Instagram, right? So this is giving off H positive, OH negative. The temperature is increasing, Kw is increasing. That means this is an endothermic process we are talking about, right? In endothermic process, temperature increases, Kw increases, right? So now let us see this. If I say that temperature is equals to 25 degrees Celsius. If I say temperature is equals to 62 degrees Celsius, okay, if I say temperature is equals to 90 degrees Celsius, in all these cases what will be the value of Kw? Okay, for 25 degrees Celsius the value of Kw is going to be, everyone, the value of Kw, everyone in the comment section, the value of Kw is going to be 10 raised to power minus 14, right? For temperature is equals to 62. For temperature is equals to Kw is going to be 10 raised to power minus 13. Okay. And for temperature is equals to 90, Kw is going to be 10 raised to power minus 12. Okay. So these are the different values. We usually know that Kw is equals to 10 raised to power minus 14 because we take the standard value. But if in the question they have mentioned that the temperature is 90 or 62, write this Kw value. Okay. If they have mentioned and something else, the temperature is this or this. Okay. Only these values will be asked if they ask. Okay. Otherwise, this is the most important. That is at 25 degrees Celsius, Kw is equals to 10 raised to power minus 14. Yes, bacho. Any problem? Any problem? Yes, is this clear to everyone? What is the ionic product of water and at different temperature? How we say that with increasing temperature the value is increasing here. Okay, this minus sign, minus 14, minus 13, minus 12, that means Kw value is increasing, the points are decreasing, right? Okay. Now let us see what is the meaning of this thing. That is 10 raised to power minus 14 is equals to K is equals to H positive and OH negative. Now this symbolizes few things here, right? The few things that are, if we say H positive, everyone, if we say H positive here, if H positive is more than 10 raised to power minus 7, thus divide this by 2. Okay, divide this whole by 2. If this is more than 10 raised to power 7, that is a acidic solution. That is a acidic solution. Okay, that is going to be a acidic solution. Now if I am talking about a basic solution, in that case I will write OH negative should be more than 10 raised to power minus 7. That is H positive should be less than 10 raised to power minus 7. Okay, H positive should be less than 10 raised to power. You can also calculate the value of pH. Okay, in that case pH will be less than this. Okay, you can also write it here that in that case pH will be less than, in that case you can write here pH will be less than 7. In this case pH will be more than 7. Okay, that is the reason for this is for acidic, this is for basic, right? Okay, and for neutral solution, everyone, what is the value for neutral solution? What is the value for neutral solution? For neutral solution we will write H positive equals to and OH negative equals to 10 raised to power minus 7, and pH here is going to be equals to, pH will be equals to 7. Okay, pH will be equals to 7. Yes, okay. Yes, bacho, this is the same thing that I have written for you. Okay, same thing. Now we have done this also. Next is, bacho, now we are going to the next part of ionic equilibrium. Till now, have you understood everything? Any problem that we have discussed till now? Any problem? Any one of you? Any problem? Yes, so that we can start with the next part of ionic equilibrium. Right, let us start with the next part of ionic equilibrium, that is very important. That is the most confusing part of ionic equilibrium, right? But we are going to solve this, okay? Okay? Okay, let us start then. Okay, let us start. Yes, ma'am. How many topics we have? Solubility chapter is left, like one and a half chapter is left. Okay. I thought we will complete in 3 to 4 hours, but no. We need one more hour. Okay, 1 hour more. 1 hour or 1.5 hour more. Right? I think by 6 o'clock we will be able to complete this chapter. Right? Okay. Yes. So now you have pH is equals to minus log H positive solution. So usually students they what they cram is that pH is equals to minus log H positive. Right? That is in general case. Whenever you have to find the pH here, when you have weak acids, combination of weak acids, you are diluting it and all that, you have to remember this particular formula, that is pH is equals to minus log H positive of solution, right? H positive of that solution. Now ma'am, what do you mean by that? Now you know that H positive will be from the acid, right? It will be from the acid and water, right? Both will give H positive. This is going to give H positive. This is going to give H positive. And we know that water is neutral. So H positive from the water is going to be 10 raised to power minus 7 at 25 degrees Celsius. Right? And for acid, it is going to be as mentioned in the question. This will be given in the question. Given in the question. Given in the question. So now ma'am, what is the tricky part here? Ma'am, what is the tricky part here? Okay. Let us see what is the tricky part here. The tricky part here is that sometimes if I write it here that H of solution, H positive, if I write here H positive of solution equals to H positive from acid plus 10 raised to power minus 7. This is applicable for precision, for accuracy. You can apply this formula everywhere. But for example, I am saying that you have this much amount of H positive from acid and you have this much amount of H positive from water. So this is so large, you will neglect this part in comparison to this one, right? So in that case, when the concentration of H positive is more than 10 raised to power minus 7, okay? It is more than 10 raised to power minus 7, it is so large. In that case, you will apply this formula that H positive of solution, is going to be H positive from acid. That's it. Okay. H positive from acid. That's it. But if I say opposite of this, if I say that you have this much of H positive from water and this much of H positive from acid. This is from acid. So now these two things are comparable. In that case, you will include the H positive from the water. So here, when you have H positive is less than 10 raised to power minus 7, the value is less. In that case, you will write H positive of solution is going to be H positive from acid plus 10 raised to power minus 7. Okay? Understood? This is going to be our main important thing. Okay? Yes, bacha? Any problem? This is what I have written here. You can, okay. For precision, we write here 10 raised to power minus 6. Okay, not 7. Okay, we write here 10 raised to power minus 6. Right? Okay, and here we write if this is less than equals to 10 raised to power minus 6. Okay, students? Any problem till now? Any problem? Yes? Okay? Yes, bacho. So also I am going to delete this one because now this is of no use to you. Right? Okay. So less is the notes, more is the quality that will benefit you. Same way we have this next formula, that is POH is equals to minus log of OH negative solution. In that case, we have if OH negative, same, it just replace H positive by OH negative. If OH negative is more than 10 raised to power minus 6, this will be equals to OH negative just from base. OH negative from water will not be included. But if we say that OH negative is less than 10 raised to power minus 6, means it is comparable to the water, right? So in that case, we will add the OH negative from the water. Okay, in that case, we are going to add the OH negative from the water. Yes, students? Okay. Now, let us do questions. Let us do the formulas for different cases. Okay, guys? So let us do the formulas from different cases. I'm not going to write the value of pH here, okay? Because pH is equals to log H positive of solution. Okay, that is log H positive of solution. Only thing that I am going to write here is the H positive from the solution. Now, if you have strong acid, okay, you have strong acid, how are you going to do that? Okay, so now let us do some questions based on that. Let us do the questions based on the strong acid. Okay, that is going to be, wait, or I can just write it here. Okay, I can just write that for strong acid, it is going to be this formula. Okay, let us do the question based on this. First question is this one. First is this question. So, I think by this question, you will be able to, the things will be very clear to you. Now, this is 10 raised to power minus 2 molar H2SO4. Now, it is giving us 2H positive. Okay, this is H2SO4. This is giving us 2H positive plus SO4 2 negative. Right? Now, let us see this. It is giving us 2H positive. If it is giving us 2H positive, in that case, bacha, what we can write here, it is giving us 2H positive, what we can write, the concentration of this acid is going to be 10 raised to power minus 2. That means the concentration of H positive is going to be this much. Okay, this is the concentration of H positive from the acid. Right? Okay. Now, the concentration of acid is very large in comparison to 10 raised to power minus 6. Okay. So in that case, what we can write, that the value, the formula will be H positive of solution. H positive of solution is going to be, H positive of solution is going to be, we are going to neglect this because this is very large. So this is going to be 2 into 10 raised to power minus 2. Right? Okay, put the value in the pH value, that is pH is equals to minus log of H positive of solution. Right? Put the value, you will get your answer. Now, next question is that you have the value, that is HCl. HCl gives us 1 H positive, 1 Cl negative. Now, ma'am, we are not using C alpha because, bacha, this is 100% dissociation. This is a strong acid, okay? We are not going to use that here, right? So, here we have this H positive from acid is going to be 10 raised to power minus 8. Now, this is less than 10 raised to power minus 6, okay? Which is less than 10 raised to power minus 6. So, the H positive of this solution is going to be, we are not going to neglect it, right? So that is why we will write it 10 raised to power minus 8 plus 10 raised to power minus 7, right? And put the value here, put the values here, you will get log, you can put the value here, pH is equals to minus log H positive of solution. Right? Okay, so it totally depends on the question what is given to you. If you will add 10 raised to power minus 7 or you will neglect 10 raised to power minus 7. Yes, students? Okay. Yes, students? Okay. Now, next thing is NEET 2019 question, that is the pH of wait. We have more questions also. I just totally forgot. Right? Okay. This is the second case. This is the first case. Now, talking about the second case here, I am writing it down here only. Right? Talking about the second case, that is for strong acid. For strong base. If you have strong base, in that case, what you are going to write, bacho? In that case, you are going to write pH is equals to minus log of OH negative of the solution. And how you're going to calculate it? You're going to calculate it from this side. Okay, this is how you're going to calculate the value of OH negative of solution. Right? Okay. Now, next that we have third one, we have strong acids. We have two strong acids. If we are talking about two strong acids, okay, if we are talking about two strong acids, in that case we are going to write down, for example, you have a strong acid NH positive and another strong acid MH positive. Okay, this first acid is giving us N amount of H positive, second is giving us M amount of H positive. Right? We are mixing this together. Now what is going to be the H positive of this solution? H positive of this solution. Everyone in the chat box, what is going to be the value of H positive of this solution? Okay, so see this. This H positive, this is in one beaker. Okay, this is in another beaker. We are going to add these two. For example, I say this H positive is having M1 molarity, V1 volume. This is having M1, M2 molarity, right, V2 volume. So after adding it, it will have V1 plus V2 volume. Okay. So the formula here is going to be V1 plus V2. Okay. V1 plus V2, everyone. What is the formula here? The formula is going to be V1 plus V2. N of M1 V1 plus M of M2 V2. Or we can say, what is NM1, NM2? The number of moles of H positive into molarity. That means basicity into molarity. Basicity into molarity is equals to normality. So here we are going to write here. N1 V1 plus N2 V2 divided by V1 plus V2. This is going to be the answer. Yes, everyone, this is going to be our answer for H positive of the solution. Right? Okay. Any problem? Now let us talk about two strong bases. Okay. Two strong bases. I'm just right now copying this. Okay. I'm going to copy this. Okay. Because formula is quite similar. Okay. Formula is similar. Few things have changed. Okay. Few things have changed. So now let us see this. If you're talking about two strong bases, okay, we are talking about two strong bases. So in that case, what we have here is N amount of OH negative, M amount of OH negative. Here the molarity is M1 V1. This is M2. The formula is going to be the same. Okay, the same formula will be applied here. Yes, everyone, the same formula is we are going to apply here. Okay, this says the number of moles of OH negative. This is the number of moles of OH negative in the second beaker. And the total volume is going to be V1 plus V2. Yes, bacha? No, bacha, this is not recorded. I am live, king. Okay? Yes, bacho, no response. Otherwise, I think I am stopping this lecture then. Okay? I see no response in the chat box, like, oh, I'm writing anything, no response in the chat box, right? So I think there is no use of taking class on Sunday. If the students here who are active, right, who are teaching, who are learning from me, but they are not responding, right? So I think then there is no use. So I think I should also just conduct this lecture for 1 hour and, do that thing, okay? We have done this, we have done that, and complete the chapter. Do you want me to complete this chapter that way? Yes? Okay. Who all are here? All the students write something in the comment section, because that way it feels like I am teaching these walls. Okay, be little active in the chat section, that you are able to understand or not. Otherwise, it will seem like a recorded video only, right? Okay. Okay, perfect. Now, next thing is, this was the fourth part. This was the fourth part, okay? This was the fourth part. Next thing is, this was the fourth part. Now, next that we are going to do is fifth one. That is for everyone. That is for strong acid and strong base. We have very, very important, okay? We have strong acid and strong base. For that, we have to calculate the value of H positive, right? For that, we have to calculate the value of H positive here. If we are going to calculate the value of H positive here, for example, we have N amount of H positive and we have M amount of OH negative, right? These are the two beakers, these are the two beakers, these are the two beakers, right? This is the first beaker, this is the second beaker. The total volume is V1 plus V2. And here we have M1 V1 as the molarity and volume. This is M2 V2 molarity and volume, right? Okay. You know what? I could have taught you with pre slides that was already written on the all the formulas. My arm is also not well, right? Okay. I'm not feeling like writing anything because of the cervical that I'm going through, right? Daily I take physiotherapy sessions. But still I am writing it on the blackboard because I know how important this chapter is, right? I know how confusing these formulas might get for you, right? And so please respond, okay? Otherwise I'll feel very sad about it. That why I am, giving myself this hard time when I can just go through the formulas, right? Okay? Yes? Okay. So now, bacha, next that we have, this is M1 V1. So for that, bacha, don't worry about me. This is H positive. This H positive of solution is going to be, okay, there are two cases for this. Always remember, we have two cases, okay? We have two cases. We have two cases. If H positive is more than OH negative, right? If OH negative is more than H positive, we have two cases here. If we say H positive is more than OH negative, in that case, bachcho, if we say H positive is more than OH negative, if we say H positive is more than OH negative, in that case, okay, whatever thing is in more, that will be, we will subtract the lesser amount with the more amount, okay. That means here we have H positive more, that means here H positive of solution, H positive of solution is going to be, this is V1 plus V2, this is going to be N M1 V1 minus M M2 V2, okay. We'll subtract the lesser amount here, right? And here we will write, everyone, and here we will write, this is going to be H positive of solution is going to be, this is the more amount here, that means M M2 V2 minus less amount is H positive, that means N M1 V1 divided by V1 plus V2. Okay, this is going to be the answer. Yes. Okay, you can also write it in place of NM1 or MM2. You can also write normality. This can be N1 V1 minus N2 V2. Somewhere you will see these formulas also. You will write N2 V2 minus N1 V1. Okay, because basicity or acidity into molarity is equals to normality. Now, next case, bachcho, that we have. So next two cases are not so much asked, okay? These are not that much asked in your exams, okay? Next is weak acid. This is not so important. Weak acid and weak and strong acid. And strong acid. So here you will get the value of H positive. Here you will get the value of H positive from two things, okay? There will be a strong acid that will be 100% dissociated. For example, strong acid has, strong acid is C2, okay? Strong acid is, this is the value for C1 is for weak acid and plus C 2 is for strong acid. So we will write C1 alpha 1 plus C2. Right? Why? Because this is 100% dissociated, this is partially dissociated. Right? This is partially dissociated. So we can write this in terms of K1, wait. This is not used this is not asked so many times, okay? Divided by 2 under root. This is C1 square plus, C1 square, okay. You will hardly see this question anywhere, okay? Because this formula is not asked so much. In JEE Advanced or JEE Mains, they might ask this, okay? But here, there's a very less chance of asking these kind of questions, okay? They will ask you from the first 5 cases. They will ask you questions from the first 5 cases, right? Okay, this is the formula for H positive. Okay, this is the formula for H positive, right? Okay, yes, bachcho. And what is the value of K1 here? What is the value of K1 here? Alpha into K1 C1 plus C2, right? Okay, yes. C2, yeah, okay. Now, last, this one is also not asked so much in your exam. That is weak acids. 2 weak acids, or we can write 2 weak acids. Okay, this is also not asked so much. Okay, simply by chance if they ask you, just need to cram this formula. Okay, that is H positive. Now both are weak acids, so both will be partially dissociated. So this will be C1 alpha 1 plus C2 alpha 2, right? So this after derivation, that will be after derivation, just give me a minute. Ka1 alpha 1 plus Ka2 alpha 2. Right? Okay. So these 2 formulas, if you can skip this, you can also, this is not very important. You can also skip these 2 formulas. Okay. But for those students who don't want to take risk, they can also learn these formulas. But the questions from these formulas are never asked in your NEET exam. Okay, so my duty is to tell you which is important and which is not important. So this is not important, right? But that is in your syllabus, so we will do that, right? Next is for weak base also. For weak base, let us do the formula here only, right? Okay, let us write the formula here only. Wait. I'm just compiling so that, things are easy. Because less are the pages, it will be easy for you to recall things, okay? So, I'm going to erase this. Same is the formula for 2 weak bases, okay? So this particular page you can skip, okay? This particular page you can skip, right? So this is going to be OH negative equals to C1 alpha 1 plus C2 alpha 2 equals to under root KB1 alpha 1 plus KB2 alpha 2, okay? Yes, so you can skip this page. Yes, everyone? Okay. Now, this is important. This 9th one is important. That is on dilution. On dilution. Okay? If you are diluting it. Now, if you are diluting anything, what will happen? You have this beaker where you have n amount of H positive. It has M1, V1. M1 is the molarity, V1 is the volume. You are adding H2O, right, with a volume V2. Okay, with a volume V2. As we know that H2 is not dissociated, it's just one molecule out of thousands of molecules that get dissociated here. So here we are not going to add the H positive from the water, right? So H positive from the water we are not going to add. We are just going to write here the normality here, that is M1V1. Here we have no H positive from the water, just one molecule out of 1000 is going to dissociate here, but the volume will increase, right? Because we are adding water, so the volume will be V1 plus V2. So this is the formula for dilution. Okay, this is the formula for dilution. Yes, students. Okay, this is the formula for dilution. Yes. So till now we have completed all these formulas. Yes, we have completed all these formulas, right? Okay. So now let us see some questions here. Okay, let us see some questions, everyone. After that, we are just left with two topics. One is buffer, then we have solubility, right? Buffer solution, then we have solubility product. Ma'am, H positive of water is not added. Yes, it is not added because out of just after 1000 molecules, just one molecule is dissociated here, right? So H positive from the water will not be added here, right? Okay. Yes, students. Now see the pH of 0.01 molarity, 0.01 molar NaOH solution will be. Okay, what is the volume? Okay, so the pH of 0.01 NaOH solution will be. What is going to be the pH here? 0.1 NaOH. Just calculate the pOH here. Okay, that is going to be minus log OH. Right? The value of OH. This is the value. This is giving 1 OH. Right? This is giving 1 OH. So this is the concentration of OH negative. After calculating pOH here, just apply this formula. pH plus pOH is equals to 14. Just apply this formula, you will get the answer. Okay, just apply this formula here. The value of pH, that will be, pH is going to be 14 minus pOH. Right, that is the value of pOH. Right, and you will get your answer, that is going to be 12. Okay, just put the value. This is 10 raised to power minus 2. Okay, so pOH, after putting the value here, pOH is going to be minus log of 10 raised to power minus 2, right? 10 raised to power minus 2. So this is going to be 2, right? So pH is going to be 14 minus 2, that is 12. Okay, so answer is going to be C. C is going to be the right answer here. Yes, everyone? Okay. Now, next case is equal volume of 3 acids. This 2008 question. Equal volume of 3 acid solutions, that is 3, 4 and 5, is mixed in a vessel. Okay, you have equal volume here, right? That means you have V, V and V. Okay, so here H positive, these are our strong acids only, right? Otherwise they will mention here weak, right? So this is going to be V plus V plus V. And here we will write down the concentration of H positive. So they have pH this. If pH is this, concentration is going to be 10 raised to power minus 3. This is going to be 10 raised to power minus 4. This is going to be 10 raised to power minus 5. Okay? Yes. So we'll add it. 10 raised to power minus 3 plus 10 raised to power minus 4 plus 10 raised to power minus 5. Volume, we should also add the volumes here because this is what? This is n amount, all are giving 1 H positive. So this is going to be M1V1 plus M2V2 plus M3V3. Right, so that is 10 raised to power minus 3V plus 10 raised to power minus 4V plus 10 raised to power minus 5V. So this will be V cut here. So this will be 3V, 10 raised to power minus 3 plus 10 raised to power minus 4 plus 10 raised to power minus 5. So we will have addition of this divided by 3. Okay. How many more topics? We have 2 topics left, that is buffer solution and salt hydrolysis. Okay, 2 topics are left. Yes, students, salt hydrolysis also one more topic. Okay, solubility product. 3 topics are left. Very important 3 topics are left. right? Okay, so this will be the answer here. So this is going to be P, right? Now let us do buffer solution, right? Okay, what is buffer solution, everybody? Buffer solution that resists to change its pH. Okay, just wait, give me a time, give me a minute. Buffer solution is which resists to change its pH, okay, which does not change its pH on addition of acid or base, right? So a solution which resists change in pH on dilution or with addition of small amounts of acid or alkalis or bases is called buffer solution. For example, our blood is a very good example of buffer solution, like it does not change its pH. Now, what are the qualities of buffer solution, everybody? So there can be three type of buffer solution that we can observe here, right? So basically, we have three kind of buffer solutions, right? We have basically three. Everybody, and can anyone answer this? What are the three types of buffer solution? How we can form acidic buffer? How we can form acidic buffer? How we can form basic buffer? How we can form salt buffer, right? Okay, so how we can form this? Can anybody answer this? Yes, students? So acidic buffer is formed when you have, everybody, when you have a weak acid, when you have a weak acid plus salt of that weak acid. That is called acidic buffer. Now, very good. Basic buffer is when you have weak base plus salt of that weak base. Okay, that is plus salt of that weak base. That is the basic buffer. Now, salt is that when you have weak acid and you have weak base. That is called salt buffer. Okay, that, or you can say neutral buffer. Okay, so we have acidic buffer, basic buffer and neutral buffer or salt buffer, right? So let us see the examples of that. Acidic buffer, I told you weak acid plus salt of weak acid. So weak acid, salt of weak acid, right? Basic buffer, weak base plus salt of weak base, right? And what is salt buffer? That is this is a salt of weak acid and weak base. Okay, that is a salt of weak acid, that is CH3 COO negative plus NH4 positive. This is from plus NH4 positive. This is from weak base. This is from weak acid. Or I can also write it here. This is a salt of everyone. This is a salt of weak acid and weak base. Okay, that is called the salt buffer. Okay. Okay, students. Yes. Don't worry, you can watch it now. Yes. Okay. So now let us see. Wait. Okay, let us see the buffer range here. What is the buffer range? When the buffer on adding, okay, when there is pK minus 1 up to pK plus 1, the value is not changing. That is the range of buffer. Okay, if you add an acid of pK minus 1 to pK plus 1, the pH is not changing. That is the buffer range. Okay, so now how do you calculate it? This is calculated by salt by acid concentration. Okay, this is calculated by salt by acid concentration. So if the salt by acid concentration is more than 10, okay, if it is more than 10, we will write salt hydrolysis. Okay, if it is more than the ratio of salt by acid is more than 10, that will be salt hydrolysis question. Okay, we are going to do it now. If we say that it lies between 1 by 10 to 10, that is the question of buffer. And here we use this formula. Okay, here we use this formula. I'll write more formulas of buffer. Okay, I'll write more formulas of buffer. Now, if you have less than 1 by 10, then we will use this formula. That is H positive equals to under root KAC. Right, that is the case of pure acid. This is the case of pure acid. This is the case of pure acid. How can we say that? Now you are dividing salt by, if This is more than 10. That means salt is more. That means it is the case of salt hydrolysis. If this is in between, that is the buffer. If we are saying this is less than 1 by 10, that is such a small value. That means salt by acid ratio is very small. That means acid is going to be very large. Okay, the concentration of acid is going to be very large. That means it is going to be a pure acid. Okay, that is going to be a pure acid. Yes, okay. Students, if you really want to gain some knowledge, knowledge is not gained in just quick hours, okay? If you want to study this chapter in detail, right, you have to spend some time here, right? Okay, so be patient, right? Even my legs are paining, but I am standing here, right? Okay, so be patient. Only patience can give you success, okay? Always remember that. Which will be the basic buffer? Now, out of the following, which is going to be the basic buffer? Everyone here, what is going to be the basic buffer? Yes, everyone. Yes, everyone, what is going to be the basic buffer? Yes, everyone, what is going to be the basic buffer? Okay, so here we need to calculate the basic buffer, right? We need to calculate the basic buffer. For basic buffer, there should be, we should have weak base. Where is the weak base? We cannot find weak base anywhere. We just can find weak base here. And the salt of weak base. It will form a salt that is NH4Cl. That is a salt of weak base. So this is the salt of weak base plus weak base. This is going to give us the basic buffer. So answer is going to be D. Okay. So D is going to be the answer. No, bacha, this is acid. Okay. This is acidic buffer. This is acidic buffer. This is acidic buffer because here you get this the weak base, this is the weak acid, and after reacting these two things we'll get CH3COONA, right? So this is the salt of weak acid, right? Okay. So here we will have D as the correct answer, which is the basic buffer. This is going to be the basic buffer. Yes, students, this is going to be the basic buffer. Now, next is which of the following pairs is not acidic buffer? Which of the following is not an acidic buffer? Right? See, this is a weak acid, this is a weak acid, this is also a weak acid. This is a strong acid. So this is not going to be acidic buffer. Right? So answer is going to be B is the correct answer. Yes, very good, very good, very good. Now, just wait, before this, I want to teach you some formulas. Okay, some formulas here. Very simple formulas of buffer solution. Just one thing, that is Ka, or we can write it here, H positive equals to Ka into acid by salt. Okay, this is for acidic buffer. Right, for basic buffer we have OH negative equals to Kb. This is base by salt. Okay, this is the basic buffer. And here, if you take log of this and subtract this, this will be pH equals to pKa, right, plus log salt by acid. So now, ma'am, how do you recall this? How do we cram this now? This is nothing to cram about, okay? Just here take the log, okay? That will be log H positive, and this is going to be log Ka. This is going to be plus log of acid, right? Plus log of acid by salt, right? Okay, after that multiply this by minus, okay? So this is going to be pH. So pH, this is going to be pKa, right? And you can also write it here minus log of acid by salt, or write here log salt by acid, right? So this is how you derive this. Okay, you can simply just recall this formula, and by that you will be able to recall this, right? Okay, so now here the formula will be, this is going to be POH equals to PKB plus log of salt divided by base, right? Okay, and what about salt? And what about salt? What about salt? What about salt buffer? Write the formula here. Wait. This is pH equals to half of pKw plus pKa minus pKb. Right? Okay? This is going to be the formula. Okay? So this is for acidic salt, this is for basic, this is for salt buffer. Okay? So these are the three formulas. Okay? Yes, students, this is going to be the three formulas. Hello? Are you awake? Or slept? Awake or are you sleeping? By now? Yes, guys. Are you awake? Or are you sleeping? Because I feel like you are sleeping. I don't know why. Hello, hello. Knock, knock. Knock, knock. Yes, you are awake. Thank God you are awake. I don't know what should I do. Oh God, such a boring lecture you have made this. This is most interesting topic, but your chat has made this such a boring lecture, oh God. Sometimes you guys should also entertain me, okay? Yeah. Okay, so now bacha, next thing is you should talk in between, otherwise this is going to be very boring. Yes? Okay, next is NEET 2011 question. A buffer solution is prepared in which the concentration of NH3 is this and the concentration of NH4 is this. If the equilibrium constant is Kb for NH3 equals to this, what is the pH of the solution? So now they are asking you the buffer solution. Okay, they are saying is prepared which concentration of NH3 is this and the concentration of NH4 is this. Okay, yes. If the equilibrium constant is given to you, what is the value of pH? Right? Okay. So this is the, apply the formula basic buffer. Okay. Apply this formula. You are given the value of Kb. You are given the value of salt and base. Okay. You are given the value of salt. This is the salt. This is the salt. This is the concentration of salt. Right. This is the concentration of base. Just apply this formula, that is POH is equals to PKB, this is KB value, this is PKB value, right? This is KB value, right? PKB plus you have log salt by base, right? Salt by base, just apply this formula and you will get the answer, right? Okay, you have everything here. After that, pH is equals to 14 minus POH. These two formulas you will use here. Okay? Yes, students? Okay? Yes. So, next students, let us see the next question here. That is very important concept, that what if you have, this is CH3CO, this is giving you, this weak acid is dissociated into CH3CO negative plus H positive, and this is Ka is the dissociation constant. Now they are saying that this weak acid, the conjugate base of this weak acid is hydrolyzed, and then this particular reaction has equilibrium constant KBC. Okay, that is the equilibrium constant of this conjugate base. Now what is the relation between these two? Okay, the relation is Ka into KBC equals to Kw, and at 25 degrees Celsius this Kw is 10 raised to power 14. Okay, so this is at 25 degrees Celsius. Now always remember, here we are using this weak acid, its conjugate base. The hydrolysis of this weak acid's conjugate base, right? We are talking about that. We can't say that this is different conjugate base and this is different hydrolysis of conjugate base. The weak acid is having a conjugate base and the hydrolysis of that conjugate base, and the relation between these two, equilibrium constant will be equals to, multiplication will be equals to 10 raised to power minus 14. Right? Okay? Very good. Now, second last topic is salt hydrolysis. Now let us talk about salt hydrolysis. Salt hydrolysis is that when you have a salt and it is hydrolyzed. Okay? So what is a salt? For example, a salt can be made of strong acid and strong base. Right? It can be made of strong acid and weak base. It can be made of weak acid and strong base. It can be made of weak acid and weak base. Right? So, strong acid and strong base do not participate. Okay? They do not give salt hydrolysis. We are going to discuss these three cases where we have either we can have one thing is weak or both are weak. Right? In this case, everything is 100% dissociated. That is why there is no salt hydrolysis on adding water. Right? But because this is partially hydrolyzed, these two are partially hydrolyzed. That is why on adding water is going to break that undissociated acid or base. Undissociated weak acid or base. Right? Okay. So let us see this. Let us see this, beta. Let us do this by our method. First, we are going to talk about, see, very simple. As I told you, formulas will be very simple for you, right? Okay, the way we are going to learn this. Okay, this is strong acid and weak base. Okay, derivations are not important for you, bacha. Right, in terms of when we talk about NEET. Right? Okay. So here we have strong acid, weak base. So first thing is strong acid, like you have HCl, weak base like NH4Cl. In that case, what is the value of here? See, H is the hydrolysis constant. Okay, this is degree of hydrolysis. H is the degree of hydrolysis. KH is the hydrolysis constant. Okay, KH is the hydrolysis constant. Yes, students. So see. Firstly, let us calculate the value of KH. What is the value of KH? KH is always going to be, students, KH is always going to be KW divided by something that is weak. What is weak here? Base is weak. So I'll write KB. I'll write KB here. Okay, this is going to be the value of KH. This is going to be the value of KH. So now let us write the value of H. What is the value of H? Everyone, what is the value of H? That is under root KH. Let's write this by some different. H is equals to under root. H is equals to under root KH by C. Right? KH is this one. Okay, so this is going to be KH. This is going to be KW by CKB. Okay, right? By CKB. This is going to be the value of this. Okay, I am going to give you simple tricks for this. Okay, see what is the trick here. See what is the trick. KH is always going to be everyone, that is going to be KW by weak. Okay, whatever we have weak. If there is weak acid, then we will write Ka. If there is weak base, we will write Kb. If there is weak acid or base, both are weak, we will write Ka dot Kb. Ka into Kb. Right? If we talk about the value of H here, how we will calculate that? We will have two things here. Okay, we will have two things here. If we have only one weak, only one is weak, like either acid is weak or the base is weak, and here both are weak, both acid and base are weak. Okay, here I'll write both acid and base are weak. Right? Okay, so we have different values for that. In this case, H is equals to under root KH by C. In this case, H is equals to under root KH. Right? Okay, guys? Yes, students, very simple. So now we know how to calculate. Now we don't need to cram these two values. Just you have H is equals to under root KH by C if one of them is weak. Right? Okay? Yes, students? Yes? Okay? Now, like we know, H positive was equals to C alpha. Here H positive, when you write this equation, when you write this is a weak acid or strong base. In that case, hydrolysis is equal, in that case H positive is equals to CH, where H is the degree of hydrolysis. Okay, so I'll write it here, H is equals to C into H. H positive is equals to C into H. That is going to be under root C KW by KB. Okay. Now just take the log of this and you will have your formula. Okay, you can take the log. It will be log minus H positive. This will be pH equals to taking the log of this half. Okay, that is going to be log Kc minus log Kc minus log Kc. You need to derive this. Okay, or you can easily derive this. See, this is minus log of H positive. Take the log and multiply this by negative, right? Okay, this will be minus this. This is log Kw minus half log C, and this is plus. This is going to be minus and this is going to be plus. This is half log Kb, right? Okay. So after solving this equation, this is going to be pH. Okay, this is going to be pH. This is going to be half pKw, right? And this is going to be minus half log C. And multiply this by half, you will have minus, and this is minus. This will be minus half pKb, right? So this is going to be a formula. Take the minus out of this. This is pH is equals to half, right? Okay, either you can directly learn the formula. If you don't want to learn the formula, you can derive it from here. Okay, so this is going to be minus, this is Kw minus log C minus pKb. Okay. Yes, students, right? Or I can directly write the formula here, that is pH is equals to half log Kw log this is minus pKw minus pKb minus log C. Okay, you can directly write this formula. Yes, everyone? Any problem here? Any problem here? Okay. Yes, I think rest is done. Now let us write the second formula here. Second sheet here. Second sheet, that is for, second sheet is for strong base. Second sheet is for strong base. Everyone, that is for strong base and weak acid. And weak acid. Okay, so how we are going to write it? We are going to change it. Here we know the acid is weak, so here I will write Ka, right? Now we know one thing is base, one thing is weak, so we will write under root KH by C, and here KH will be Kw, and here we will replace this by Ka. Right, because acid is weak. In this case, H positive is equals to CH, that is going to be Ka here, right? And just apply this formula here. This is going to be Ka. Okay, this is going to be Ka. Right? Okay, everything else is same. Now students, any problem? Wait. One thing we have not substituted here, that is, this is OH negative, right? And this is POH. And this is POH. This is POH. And what is the value of pH? Is equals to 14 minus POH. Right? Simple. Any problem here? Yes, same formula, same thing. Now let us write it for weak acid and weak base. Okay, let us write it for weak acid and weak base. Both are weak now. Okay, both are weak. Now when both are weak, what we will write? Weak acid and weak base. And weak base. Both are weak. Okay, both are weak. So tell me one thing. If both are weak here, if both are weak, what will be the value of KH? That means KW by weak. Here we say both are weak. Here both are weak. So here we will write Ka into Kb. Right? Ka into Kb. Because both are weak here. Right? So both will be multiplied. Right? Okay. So what is the value of K? Acha. Here, what is the value of H? If both are weak, the value of H is going to be under root KH. Okay? Under root KH. So that means here I will write, everyone, here we will write, here what we are going to write, under root KH is equals to under root KW divided by Ka dot Kb. Right? Okay? Here also OH is equals to, OH or H positive both will be equals to CH. Okay? That is, we can write here, wait, the formula will be direct, that will be H, okay? This is going to equal to H. Here there is little change here, right? Here we have little change, that in this case, H positive, or we can directly write H positive here, okay? Or we can directly write H positive here, that H positive will be equals to, H positive will be equals to H, that is under root KW, I am writing it here, H, that is under root KW divided by Ka dot Kb. Right? Okay guys? Yes everyone? Yes everyone? This is equal to, made the shortcuts for you, right? Made the shortcuts for you. That is H positive is equals to Ka into the value of H here. Okay? This is simply so that you don't need to cram all the formulas. Okay? This is so that the cramming is less and you have less things to cram. Okay? Now you have Ka into, this is H. H is under root KW by Ka into Kb. So that will be cancelled out, and here you will have the formula as under root Ka into Kw divided by Kb. This is going to be the answer. Right? Okay? And taking the log here, pH equals to half. Okay? After taking the log here, we will have half. Okay? This will be minus, this will be minus. It will have log, or we can directly write P Ka plus, or you can write it here, PKW plus PKA minus PKB, because it is in the division. Right? Okay everyone? Yes? Just taking the log, we wrote this formula. Right? I have not crammed any of this formula in my entire life. Okay? Because I don't have very good memory. Right? I like to take things light on my head. Right? So that is what I teach my students. Try to find a way where you have less cramming. Okay, so in this case, just take out the formula from this one, because whenever you are in panic state, you are in the examination hall, you will do some sort of silly mistake in plus or minus. That is why I say learn this formula and take the log. If you know how to convert this into this, by your brain only, not deriving it thoroughly, then things will be very easy for you. Yes, students. So by this we have completed salt hydrolysis. Right? Now just one little topic is left. That is one little topic. What is left, everybody in the chat section? What is left? What is left? Just one topic is left. Let us see if you know what is left. Right? One topic is left. What is that topic? What is that topic, everybody? What is that topic? What is that topic which is left? Solubility product. Very simple topic. Okay, most simple topic. Like very simple topic. Right? Okay. So that is solubility product. Very good. Yes. Now let us solve the question based on this. Okay, then one topic, that is solubility product, is left. Calculate the pH. Okay, here we are going to calculate. We thought that we will finish by 6. We are going to finish by 6. Okay, so basically it took us around 5 hours. Okay. So calculate the pH of 0.1 molar aqueous ammonium cyanide solution. Right, calculate the pH of 0.1 aqueous ammonium cyanide solution, pKa. pKb is given to you. Very easy. Very easy. You know the value of pKb, pKw. Just put this formula here. This is a salt, okay? This is a salt. This is ammonium cyanide is a salt, right? NH4, NH4Cn. This is a salt, right? So here pH equals to half. This is pK, this is pKw plus pKa minus pKb. Right? Put all the values here. What is the value of pKw? That is 10. This is 14. Right? Kw is equals to 10 is to minus 14. pKw is equals to 14. What is the value of pKb? That is all. pKa is given to you. pKb is given to you. Just need to put the values here. Very simple question. Yes, very simple question. Yes. Okay, everybody. Just put the values, solve it yourself, and you will get the answer. And you will get the answer, that is 9.13. Okay, you just need to put the values here. Yes, everybody. Yes, everybody. Okay. Wait. The pH of have I done something wrong? Calculate the pH of 0.1 ammonium cyanide solution. pKa is given to you. Okay. This is salt by base. Just give me a minute. Just a minute, just a minute. Let us see that what we will get from that formula. Okay, just give me a minute. This is log this is log pKb is also given to you. But this is given to you, no? pKb is given to you. pK is also given to you. Right? Okay. pKb is also given to you. pK is also given to you. .4. Okay. Let's put the values here. What you get by putting the values here? Okay, what you get by putting the values here, everyone? What you get here? This is half. 14 plus pK is 9.02 minus 4.76. Okay, what you get here, everyone? Yes, we are just left with one topic. I'll do my fast calculations here, right? Okay, 9.02 minus 4.76. B is the answer, right? So you just apply this formula, okay? Apply this formula, don't apply this formula, okay? You can simply apply this formula, right? Okay? I'm deleting the answer sheet here, okay? So, okay. So just apply this formula, right? And you will get the answer, okay? If applying this formula, we get the answer 9.13. Okay? Yes, students. Now, let us do the next part, that is solubility. Now, what is solubility? Here, they can ask you the conceptual questions as well as the formula-based questions. Okay, the formula is not that much. It's a very simple formula, right? Okay, but now let us talk about different kind of solubility. Solubility is that which is getting dissolved. Okay, so there are three kind of salts. One is soluble, that is slightly soluble. Third is sparingly soluble. Soluble is that solubility is more than 0.1. Okay, that is solubility is more than 0.1 molar. When slightly soluble, we say it is between 0.01 and 0.1 molar. When we say sparingly soluble, is a very less. It is so less that it is less than 0.01 molar. The solubility is very less. Okay, so these are the three salts here. Now you have this. Okay, so see, let us derive this. Okay, let us derive this. So for example, you have A, X, B, Y. Okay, this is going to give you X amount of A positive and Y amount of B negative. Right? So in this, simply what you are going to write here, simply bacha, simply what you are going to write here, very simple that you are going to write here, that is very general formula, that is KSP. Okay, or you can just write K equilibrium. Firstly, let us see how we derive this. This is A positive raised to the power X. This is B negative raised to the power Y. Okay, divided by AXBY. Okay, this. Now this multiplied with this will give you one new solution. Okay, this is going to give you this thing. There also will be water, right? This is going to give one new solution. Okay, so after solving this, we are going to get a very simple formula, that is KSP equals to, right? Just simple thing. These are the two stoichiometric coefficients. What we are going to do? X raised to power X, Y raised to power Y, solubility of X plus Y. Okay, the concentrations here are expressed as solubility or as solubility. Okay, this is the solubility and this is the solubility product. Okay, simply write this. Okay, for example, if I have any question, for example, I have any question that is CaF2, right? Write the solubility product for this. The solubility product is going to be, this is going to give us Ca2 positive plus 2F negative. Right? So this will be, this is X, that is 1, and this is Y. Okay? This is Y. Right? So this is 1 raised to power 1 raised to power 1 into 2 raised to power 2 plus 1 raised to power 1, 2 raised to power 2 plus solubility of 2 plus 1. That is going to be 4S cube. Okay, this is going to be the formula of solubility product. Right? Okay, everyone? Yes. Salt as a basic buffer. Is that solution they considered salt as a basic buffer? In which solution? But we have applied a very general formula. Okay, we have applied a formula when you have hydrolysis of ammonium cyanide. Okay, this is the correct way of doing this. Right, this is the formula that we have seen here. Okay, this is the formula. We have weak acid, weak base. Okay, this is a salt of weak acid and weak base. Okay, yes. Okay, now next part, everyone. For example, if we talk about the common ion effect, this is the common ion effect. Okay, common ion effect. For example, I am saying you have CaF2 that is getting dissociated to Ca2 positive plus 2F negative. Right? And then you have NAF. You have NAF that is also giving us Na positive plus F negative, right? So the equation, we know that this F negative will be a common ion, okay? This will be a common ion for this one and for this one. For example, they have given you the concentration of NAF is, given to be 0.1, okay? If this is 0.1, this is also going to be 0.1. So this 0.1 we are going to add here. This is 0.1 plus this 2s, okay? 2s is the solubility. This is s, right? Okay, so this is at equilibrium. So the answer here is going to be, if we say the answer for solubility product is going to be, the answer for solubility product, okay? Let us write the answer for solubility product here. Yes, everyone? So common ion questions are also asked in your syllabus, right? So this is going to be, you have, this is the main thing, right? So this is KSP equals to, this is equals to S raised to the power 1, because this is stoichiometric coefficient is 1. Here you have 2s raised to the power 2, because here the stoichiometric coefficient is also, because the solubility equilibrium constant means the concentration or solubility raised to the power the stoichiometric coefficient. So you have the solubility, okay, this is 2s raised to the power the stoichiometric coefficients, plus you have this from the NAF, that is the common ion, right? Okay, so this is S1 into, you have this 0.1. So now you know what? Here what you can write, see, here what you can write, that this will be approximately equals to 0.1. Why? What is the reason? Why, everyone? What is the reason I am writing it here? What is the reason this is neglected? Because we can say that this S square is very small. Okay, solubility is very small. So S square will be very small. S cube will be very small. So you can say we can also neglect it here. No, bacha, we cannot neglect it here. Okay, if it was only 2s square, we cannot neglect it then. Otherwise, this would be 2s square only, right? And the formula, if there is no NAF, right, the formula would have been s cube, that is 4. That is same that we got from applying the direct formula, that is, this is 1 raised to power 1, this is 2 raised to power 2, and this is s 2 plus 1, that is 3, that is 4s cube, right? Applying the direct formula. Or we can write it here, s raised to power 1, 2s raised to the power 2, that is 4, right? This is s cube. We got the same answer, right? But when there is common ion, this common ion, we know this common ion, 0.1 molar concentration will be added here. Okay, when we add this concentration, when we are adding something, 0.1 in comparison to 0.1, this will have, this s square will have no value. So this will be approximately equal to 0.1. So we are going to write here, this will be s, this is 1, just 1, this is just 1 stoichiometric coefficient. Here you have F negative is 0.1, this is 0.1, and you have stoichiometric coefficient is not, no, this is not raised to the power, wait. This is 0.1 from this one, right? And this is 2s squared. Okay, this is from this one, okay? So 0.1 will be multiplied, only 0.1 will be multiplied here. So this is going to be the answer, right? 0.1 into solubility. This is the, or you can write the general formula here. I'm writing the general formula here, okay? I'm writing the general formula here, okay? For this one, right? For example, this is M, okay? So this is going to be M here, okay? M will be added here. M will be added here, okay? Approximately equal to M, right? Okay, everyone? Yes? Perfect? Okay, no problem here. Yes, students? Right? Are you facing any problem here? Can we move ahead? Okay. Now, these stupid persons, I don't know what they get by doing this. Okay, I don't know what they get by doing this. Now be blocked. Now you are blocked. Be happy. Now solubility product and ionic product. Okay, solubility product and ionic product. Everybody. Now we have KSP is less than ionic product. What is the difference between solubility and ionic product? See, we know reaction quotient. We know equilibrium constant. Right? Same is reaction quotient is ionic product and equilibrium constant is solubility product, right? When we say the reaction is not at equilibrium, then we say it is an ionic product. When we say the reaction is at equilibrium, then we say it is a solubility product. Okay, so we can write at equilibrium and here not at equilibrium. Okay, here we can write not at equilibrium, that is ionic product here. Right? Okay, students. So here what we are going to write, KSP is less than ionic product. That means there is no solubility. The solubility is very less now. Okay, that means it is going to form precipitates. Now when solubility is more, solubility product is more, then there will be more salt because more salt will be dissolved here. Right, there will be more solubility. Right, KSP is directly proportional to solubility. When you have KSP equals to this means you are at equilibrium. Right, at equilibrium KSP is equals to ionic product. Yes, everyone? Okay. What happens to the salt states when it is in equilibrium? Salt state when it is in equilibrium. I didn't get your question, bacha. I didn't get your question. Salt state when it is in equilibrium. What does that mean? Whatever we are reading now, right? Equilibrium means the concentrations are same, right? Okay. We have studied equilibrium. That was for salt also, right? Okay. Now, next thing is the solubility product. But we have discussed this, right? We have discussed this formula as well, right? That's why I am deleting this page now, right? Then we have common ion effect. We have also discussed this, students, that when you have Na, for example, this is 0.1, so this is 0.1. So after that, what will be the answer? Just wait. Okay. This should be m square, okay? This should be m square. This whole thing will be squared here. Wait. We will take square of this whole thing. That is 0.1. The new concentration is 0.1 plus solubility 2s. This is 2s. This is the new concentration, right? That is approximately equals to 0.1. Yes, that is equals to 0.1, right? Okay. So now what we can write here, now as we know, this is having just one stoichiometric coefficient, this is having two stoichiometric coefficient, so it will be m square. Okay, this will be m square, or we can say 0.1. I am writing 0.1 only because I don't want to generalize this because different questions, different things will be there, right? Okay, so same thing we can write, we can see here. Okay. Now everyone, very important concept. Very important conceptual questions. Okay, very important conceptual question. For example, you need to calculate the solubility, the precipitation rate. Okay, so this is a conceptual question. They ask you if the number of ions are same. Okay, if the number of ions are same or different. Based on that, you have to calculate this. If I say the number of ions are same, in that case, solubility is directly proportional to KSP, right? Solubility is directly proportional to KSP. It is inversely proportional to precipitate formation. That means if I say that you have AgCl, you have AgCl, you have NaCl, right? Then you have LiCl. Okay. So here You see, number of ions are same. All of them are giving 1 Cl negative. All of them are giving 2 ions, okay? 2 ions, okay? So that means number of ions are same. Number of ions that they give is same, right? Okay? So here, if I want to calculate the solubility rate, okay? The solubility rate, for example, they have given you the Ksp value, that is x, this is y, this is z. Okay, and x is more than y than z. Okay, so here the solubility rate is directly proportional to Ksp, right? That is directly proportional to Ksp. So what I'll write, this is the value of Ksp, right? So what I'll write, solubility rate is going to be, solubility rate is going to be same as the rate of Ksp, right? So rate of Ksp is AgCl, then you have NaCl, then you have LiCl. So solubility is going to be AgCl, then you have NaCl, then you have LiCl, because here we have same number of ions. So for calculating the solubility, we are going to see the Ksp, right? Okay. Now if they ask you to calculate, the precipitation rate will be always opposite to solubility rate. Okay, so that is AgCl, then you have NaCl, and maximum will be of LiCl. More is the solubility, lesser is the precipitation, right? Solubility will always be inversely proportional to that. Okay, so always remember this. In this case, see, these are very important, okay, very important. This is very, very important, because students usually get confused here. When you have number of ions different, okay, when you have number of ions different, for example, I have AgCl, I have AlCl3, I have MgCl2, right? This is X, this is Y, this is Z, and Ksp rate is like this. This is the Ksp. This is the value of Ksp. Now, the student who has no knowledge what it will write, that student is going to write solubility rate is going to be proportional to Ksp. He will write AgCl, then AlCl3, then MgCl2. This is the wrong answer. Because when the number of ions are not same, in that case, solubility is not dependent on the Ksp rate. That is dependent on the, solubility is dependent on the number of ions, okay? This depends on the number of ions that you have. Okay, this depends on the number of ions that you have. So, here, solubility is going to be, the answer is going to be AlCl3. It is going to give us 4 ions. Okay, write it here. Number of ions different. Okay, number of ions are different. Number of ions are different here. Okay, so this is AlCl3. Then you have MgCl2. Then you have AgCl. Okay, then you have AgCl. Yes, then you have AgCl. Now, if I say the solubility number, now if we talk about the value of precipitate formation, precipitates, when you have number, precipitates are always inversely proportional to Ksp. Okay, always, in any case they are inversely proportional to Ksp. So see the Ksp value, so that is going to be AgCl, then you have AlCl3, then you have MgCl2. Yes, so this chart is going to help you for that. If you have same number of ions, solubility is proportional to Ksp, and Ksp is always inversely proportional to PPT formation. But in different ions, solubility depends on the number of ions, and Ksp is always inversely proportional to PPT formation, precipitate formation. Yes, students? Yes, everyone? Don't worry, I have already... are you able to... I am not able to see any comments here. Wait, just give me a minute. I thought I was able to, oh god. Just give me a minute. Okay. Yes, I was not able to see the comments, but now you won't be able to see the comments either. Yes? Okay? But our students are here to give them the answer. So guys, any problem? Any problem? Now let us do some questions based on this. Let us do some questions. First is the solubility. Find out the solubility of NiOH twice in 0.1 molar. Okay, you have to find out the solubility of NiOH twice in 0.1 molar NaOH. Given that the ionic product of NiOH twice is 2 into 10 raised to power minus 15. Now students, what is going to be the answer? Find out the 2020 question. Okay, this is 2020 question. Find out the solubility of NiOH twice in this of NaOH. So NiOH, this will have common ion effect. Okay, this is going to give us Ni2 positive plus 2 of OH negative. Okay, this is going to give us this. Now, after that, what we are going to do? This is going to give us this, and this NaOH is also going to give us 0.1 molar OH. Okay, so this is going to be S, and this solubility here is going to be 2S plus 0.1, that is approximately equals to 0.1. So KSP is going to be S into 0.1 square. Okay, so that is going to be the value. Given that the ionic product, okay, the ionic product is given to you, that is KSP value is given to you, right? Okay, so put the value here, 2 into 10 raised to power minus 15, right? Okay, and you will have the answer for solubility. So solubility is going to be 2 into 10 raised to power minus 15 divided by 0.1 square. Okay, just solve this question, you will have your answer. Okay, yes students, yes, okay. Just solve this and you will have your answer. Okay? Yes, just solve this and you will have your answer. Answer comes out to be A. Right? A is going to be the answer. Simple basic calculations are left. Okay? Now, next thing is pH of saturated solution is of CaOH twice is this. Okay. The solubility product of KSP of CaOH twice. pH is given to you. Okay, from pH calculate the value of H positive. pH is given to be 9. That means H positive is given to be 10 raised to power minus 9. This is going to be the value of H. That is H is going to be 10 raised to power minus 9. Okay. Always if pH is 9, that will be 10 raised to power minus of that pH. Okay. So this is okay, also write it down here, okay, also write somewhere that pH, that if you have to calculate H positive equals to 10 raised to power minus of pH. Okay, this is another important thing that you will use in your questions. Okay, now next thing is pH. Now what is the value of OH? What is the value of C? You can simply write it here. If pH is this, for 5 will be OH, pOH is going to be 5, so OH negative is going to be 10 raised to power minus 5. Okay, right? Okay, so you can also write it here. OH is equals to P minus pOH. Okay, this is second formula. Okay, this is the second formula. Okay, these are the two important formulas to solve the questions. Okay, so now next thing that we have, if we know the value of OH negative, that it is going to give 10 raised to power minus 5 OH negative. Now let us see CaOH twice is going to give us Ca positive 2 positive plus 2 into OH negative, right? Okay, so in that case this is already given to us that this 2s equals to 10 raised to power minus 5. That means s is equals to 10 raised to power minus 5 by 2. The value of OH is already, students, ma'am, you have to write 2 into this. But they are saying that the pH of saturated solution of this is this much. Okay, so from this solution, this is OH negative from CaOH twice. Okay, this is OH negative from CaOH twice. That is 2 OH negative. Here they are giving the value of 2 OH negative only. Right? That is the value of 2 OH negative only. Right? So 2 OH negative is equals to 10 raised to power minus 5. Okay? Yes, so 2s is equals to 10 raised to power minus 5. S is going to be 10 raised to power 5 by 2. That's it. If you know this, the answer will be easy. Now, KSP is equals to, this is 1 raised to power 1. I'm writing it here. KSP is equals to 1 raised to power 1. Right? Dot 2 raised to power 2 solubility of 2 plus 1 3. So this will be 4s cube. Right? This will be 4s cube. Right? So just put the values here. Put the values here, everyone. Just put the values here. This is going to be 10 raised to power minus 5. Right? Okay? Just put the values here. You can simply write it here like this. Okay, solubility is not given to you, right? Solubility is not given to you. So just put the values here. KSP is equals to, this is 10 raised to power by 2 into 10 raised to power minus 5 square. Okay, this is going to be the answer. Yes, everyone, this is going to be the answer. Just solve it and you will get your answer. Okay. You have S, this is 10 raised to power, this is half into 10 raised to power this. The answer is going to be this. Okay? So just solve this. Next is, so easy questions are asked, right? Okay? The molar solubility of CaF2. This is a molar solubility of CaF2. KSP is given to you 0.1 solution NaF. Same question. Okay? 2019. We have already done this. Okay? This is common ion, right? We have already done this. This is CaF that have Ca2 positive plus F negative, right? CaF2, right? It has Ca2 positive plus F negative, right? After that, what we are going to get here, this is F negative, this is 0.1 plus S approximately equals to 0.1, right? This is 0.1 is from NaF and this is S, and this KSP is going to be S into 0.1 square. Okay, just put the value of solubility product. Solubility is going to be 5 into 5.3 into 10 raised to power minus 11 divided by 0.1 square. This is going to be the solubility. Right? Okay? Yeah. Here let us write 2F. Okay? This should be 2S. Yes, this should be 2S. Right? Thank you, Bacha. Thank you. This should be 2S. Approximately equals to 1. This is going to be the answer. Okay, guys? Yes? Yes, everyone? Okay. Very simple. Just put the values here and you will get your answer. Right? Just put the values, you will get your answer. Now, last thing is that we have already done in practical chemistry. One thing more, I think... somewhere I have written CaF only. Just give me a minute. Okay, right. Okay, just see this. Acid-base titration. We have done this in practical chemistry in detail. So, bacha, what is this acid-base titrations? Suppose you have indicators, you have endpoint. Okay, what is this endpoint? What is this equivalence point? Equivalence point, for example, you are titrating it. Okay, you are adding phenolphthalein, you are adding methyl orange, you are watching that when there is color change, that is your point when the reaction has happened, right? That is the start of that reaction. So what we are going to write here, that equivalence point is that point where the reaction was expected, right? So the point at which the reaction between acid and base theoretically complete. Okay, then we say that theoretically it was expected. But end point is that while doing the experiment in the lab, we find out that at this particular point, the reaction has, completed. That is why we see that color change, right? That is the main application of indicators, right? Okay, so point at which the reaction between acid and base is observed to be complete, pH at which time indicates a change is color. Okay, so now next thing that is important for you, these are all the formulas that we have studied, right? These are all the formulas that we have studied. Okay, pH is equals to P natural log, okay, log 10 this and this, right? We have studied this. This is the indicator, right? What it is producing, right? We have studied these, right? We have studied these equations. Now, next thing that is important for you in this is, for example, you have strong acid against strong base. In that case, you can use both phenolphthalein or methyl orange, right? But what kind of question can be asked, right? Now, second is strong acid against weak base. If you have strong acid, in that case, I'll write, for strong acid, you cannot use phenolphthalein. Here, you can only use methyl orange. Okay, here you can only use methyl orange. Phenolphthalein you cannot use here. You can use methyl red and bromocresol green, methyl orange. What they ask you, they will ask you about the methyl orange or the phenolphthalein, right? Okay. Next thing is weak acid against strong base. Now we have strong base against weak acid. Here we are going to use phenolphthalein, not methyl orange. Methyl orange cannot be used here. We have done the reasoning and everything in practical chemistry, experimental chemistry, we have done that. Okay, next is weak acid against weak base. When both are weak, we cannot use either phenolphthalein nor we can use methyl orange. So no indicator is suitable for this. So always remember, for weak acid we use phenolphthalein, for weak base we use methyl orange, right? Okay guys, yes. Now, very simple, very good, very good, very good. Now tell me, is ionic equilibrium difficult? Now everyone in the chat box, tell me, is ionic equilibrium still difficult for you? Because the way I have formulated the formulas for you, okay, the way I have derived the formulas for you, that will be very easy for you to recall, okay. We have made all these formula sheets, okay. In between the class, we have made all these formula sheets. Let me show you. Okay, these are the formula sheets. Wait. Where are the formula sheets? Okay, these kind of formula sheets are going to help you a lot. Okay, so we know, okay, these kind of formula sheets, right? You know what is the basic concept behind that. Then things will be very easy for you. Now you just have one task here. Okay. That one task is to give the PYQs test here, right? Give the PYQs test here, bacha. Give the PYQs test. After revising, I'll provide you the notes, right? And then after, go through the NCERT solutions, right? These are the NCERT solutions of equilibrium. Then, bacha, go through the NEET PDF NCERT PYQs. Go through them, okay? And try to understand, okay, what are the concepts where you still feel less confident, and what are the concepts where you feel confident. Okay, then revise it again, and if you feel any problem, if you face any problem, write it in the comment section. Yes, everyone, do not procrastinate now. You do not have time for the procrastination. We are going to complete the syllabus, right? We have completed class 11th physical chemistry. Right, we are just left with class 12 physical chemistry 3 chapters, and redox reaction I'll do with electrochemistry itself, right? I'll combine redox reaction and electrochemistry together because they are also combined in your NEET examination, right? So they will ask you like from the combination only, right? They are totally interdependent on each other. And now we are just left with 3 things. Tuesday we are going to do solutions, and after that, bacha, after your biology exam, we are going to do, okay, because there are so many students who have board examination, I don't want to create that much of a backlog for them, right? So after that, we are going to cover chemical kinetics and electrochemistry, Electrochemistry will be a long session just like equilibrium. Chemical kinetics is very small chapter and very easy chapter. Electrochemistry is also a very easy chapter. Trust me on that. When I'll teach you, you're totally going to fall in love with that chapter. That's my promise to you. Okay, everyone. No to procrastination. Very good, very good. Easy one, 80% rest, 20% by practice. Very good, bacha. Very good. Okay. Okay then, bacho. Bye-bye. Take care. Now, enjoy your Sunday. Enjoy means just take a rest for 1 hour and sit and relax. After, or you can just sleep for 1 or 2 hours. Take a break and after that start doing the practice. Okay, I want you all to complete the practice of this chapter, these 2 chapters by today itself. Okay, do you all promise me that you will all complete the practice by today itself? Everybody in the comment section, do you all promise me that? Yes, everyone in the comment section. Yes. Okay, and now namaskaram. Okay, I'll see you on Tuesday for solution chapters. Bye bye. Take care. See you all on Tuesday.